Hello, everyone, and welcome to SQL for Data Analysis. My name is Derek. I'm with O'Reilly Media, and I'll be helping to facilitate the class today. We'll be kicking things off shortly, but before we dive into the content, I'd like to go over a few quick housekeeping items to help you get the most out of today's session. So first and foremost, at the top right corner of your screen, you'll see a set of widgets. The two we'll be using the most today are the Q&A and attendee chat. You can go ahead and open those up now if you don't already see them open on your screen. Please note that the chat feature should not be used if you're subject to regulated communication restrictions. Also, keep in mind that others in the audience today may include fellow professionals, vendors, or even competitors. We hope you'll take advantage of the interactive tools, but please be cautious about what you choose to share. This course is also being recorded, including any participation from attendees. So if you do take part via chat or Q&A, please do not post any personal information like your email address because that will be included in the recording. You'll receive an email within the next 24 to 48 hours with a link to the session recording so you can review or catch up on anything you might have missed. And finally, at the end of class, you'll see a short course evaluation on your screen. Your feedback is important to us, so if you can take a brief moment to fill out the survey, it's very much appreciated. All right, well, with that, I'd like to turn it over to your instructor for today, Kimberly Fessel.
Thank you very much, and good morning, or good afternoon, or even good evening to all of you. This is the SQL, as I say, or SQL for Data Analysis course. And we're going to be, the subtitle there is Practical Techniques for Cleaning, Joining, and Analyzing Data. And that's exactly what we're going to be doing today. As I mentioned, my name is Kimberly Fessel. I have a PhD in applied mathematics, and I've been a data scientist for about 10 to 12 years now. But I'm also a data educator, so that includes doing events just like this one, as well as my book, Head First SQL Second Edition, is coming out with O'Reilly later this year. I'm also the founder of a company called Dr. Kim Data, and there I help clients come up with data solutions for all kinds of messy data and all kinds of educational components as well. So I just wanted to go over the learning objectives for this session in order to kind of set the stage of what we're going to be doing today. By the end of this session, you should be able to clean and transform data directly in SQL. And that's really important. Sometimes people take data from SQL, transfer it over to some other place, and then do their data cleaning there. And that's totally fine, but sometimes it's better to just keep working with SQL in order to do some of your data transformations before you even export any kind of data. It can make things a lot speedier, that you're getting exactly what you want directly from SQL. So we're going to spend some time doing some data cleaning there. We'll also talk about combining and querying from multiple tables. Now, we're not going to dive too deeply into joins. I have a feeling that a lot of you already do some of those, but I'm going to show you some things around subqueries and around common table CTEs, common table expressions, as well as we are going to be doing a little bit of joining, but some kind of specialty joins as well there. You'll also be able to perform complex aggregations and rankings. And so by that, I do mean window functions. We are going to dive deep into window functions more toward the end of this session, which are some of my favorite things to do. And lastly, my other favorite thing to do here is solve real-world problems through common analysis patterns. So we're actually going to dive into problems that come up all the time that you're going to see over and over again about cohort retention and about top N per group. Those kind of things come up in a lot of different situations. So I'm going to teach you some patterns that you'll be able to apply when coming up against those kind of problems and how you'll be able to solve those with SQL. So before we dive too deeply into any of this content, I'd like to start off with a poll question. So thinking about SQL and what you already do with it, what trips you up the most often? Is it the missing values, the messy strings and dates, joins and unions, or translating business questions into SQL? Which of those things kind of causes you the most grief? Got a couple of answers trickling in here, and I'll show you the results of those in just a minute. Personally, I think all of these are very important. Personally, I kind of, not to skew the poll at all, but I think translating business questions into SQL can definitely be an area that I see a lot of people focus on. Okay. All right, let's go ahead and take a look at the results there. Yep, I wasn't wrong. Translating business questions into SQL is certainly one of the places that can cause, I don't want to say issues, but can definitely, make you think a little bit more about exactly how can I take what I need to get and put that into SQL. So yeah, totally agree with that one. Okay, we're going to spend time on all of these today, but especially that translating questions into SQL. We're going to be doing that throughout the entire session, so you're in luck here. All right. So we've already talked a little bit about the learning objectives. Just to concretely say, what does that mean for our course overview? We're going to start with data cleaning, missing values, casting, strings and dates, and case expressions there. And we're going to move into finding and joining. So that's going to be your subqueries, your CTEs, your joins, and your unions. The next session will focus on window functions. So I'll just show you the basics. If you've never written a window function, that's totally fine. We'll talk about what that even is and how you do window functions. And I'll also show you how you can use them to do ranking or summary statistics, and even how to use them to create running totals. And our last section for this session will be called analysis patterns. And that's where we're going to dive into how to translate, common data problems into SQL code. Things like month-over-month growth and so on. Okay. All right, so to do all these things, we're going to need some data to practice on. So if you can visit the course GitHub page. I'll show you how to do this in just a minute, but if you want to go ahead and do it as I'm explaining, that's totally fine. We have some materials available for you on github.com/confetti/SQL_DA_live. So if you want to visit that, there are a couple of files there that may help you along today's journey. And the first one, so I'll just show you a screenshot of what you're going to see, and we're going to actually do this live as well, so don't worry, plenty of time to do this. But when you visit that link, you should see something like this. So it's a repo that I set up for this course. And the file that's going to kick us off, that's going to help us actually have some data to query, is called learning_platform.sql. That's the file that we're going to be using, and we'll be importing that into our SQL GUI that we'll be able to analyze some data with that. Once you click on that, you should see a file that looks something like this, and it's just SQL code. It's going to help us automatically, like once we run this in our learning platform there, we'll be able to actually look at some tables in the database. Okay, so if you want to download a copy of this, you're just going to click on the download button right there. And once again, I'll walk through all of this with you live so you can see how to do it. But if you want to be getting that file ready, that's perfectly fine. Okay. Once we have that file, we'll be able to go to our sandbox for the course. So this is going to look something like this. We can provide a link for that. If you don't see it, should be in your resources. But this is going to be the sandbox for the course. And for the purpose of this course, because we do have a .sql file that we'd like to import, we're actually going to be going to this PHP MyAdmin. So that's the button we're going to be clicking on so that we can be taken to the GUI, which I believe I have a screenshot of that. It should look something like this. Once you're in this PHP admin, MyAdmin, all we're wanting to do is import that SQL file. And that's where we're going to be putting in the SQL file, and we'll be able to run some data then. Just want to make sure, can everybody see my slides? Just let me know if not. Okay. All right, great.
I can see your slides.
Okay, great. Thank you. Making sure. All right, we're still working on the slides for now. I will screen share and demo all of this in just a bit. Okay. All right. Before that demo, I did just want to show you there's one more file within the GitHub that may help you, and that is a database diagram. So there's another file within the GitHub that will show you how all the tables are interconnected. And that can certainly be helpful when you're first learning a new database like this one, to show you kind of what tables are available and what goes with what. You'll be able to see a little bit of this in the GUI as well, but sometimes just having a visual representation can also be helpful, and this is also available in the GitHub repo. Okay. All right, so let's go ahead and proceed and do all of those things I just talked about. I am going to share my screen now so you can see how to do all of those things. So first I'm going to go to the GitHub link, and so let me go back here and show you. This is the address I'm going to visit. It is github.com/kimfetti/SQL_DA_live. So this is what I'm going to start with, and then I'm going to go into the sandbox and show you how to load everything. Okay, great. So here's the GitHub. There's really just 3 files in here. It's a pretty small repo. We have the README, which tells you a little bit about the course. And then we just have those 2 files. The first one being the .sql file, which you will be able to download and import into the sandbox. And we also have the .pdf file. That's going to be your database diagram. So if you'd like a copy of that, you're welcome to click into that .pdf and download it as well. For now, I'm actually going to click on the .sql file. And that will take us to this file here, learning_platform.sql. I'm going to download a copy of that. So the download button is, so we're looking at that top where it says code and blame, and then on the right-hand side, raw, and then has a couple of extra buttons. The download button is the one that is an arrow pointing down. Okay. Once you've got a copy of that, once you've been able to download the raw file, you can go over to the sandbox. I'm going to switch my screen over. Starts out something like this. You can click Start. All right. And we're not actually going to be using this screen at all. So it's okay if the session expired or something like that. That's okay. What we're going to be using is this PHP MyAdmin. And if it's not working, I might just refresh this. Mine wasn't, I guess the session maybe ended here. Wow. There we go. All right. I was being a little impatient. Okay, so you should eventually see a screen like this one, the PHP MyAdmin. Let me increase that for you a little bit. And what we'll want to do now is, because we already have that .sql file from GitHub, we're going to import that. So I'm going to click on the import button. And I should see a screen like this one pop up. And basically all I need to do is import that .sql file. I'm going to click on Browse so I can go find the file. And you won't see the screen pop up, but basically it just pops up saying, where is this file located on your computer? Mine's in my downloads folder, or wherever you normally download things on your computer. So just want to find that file and click open. If you've been able to find that, you'll see this learning_platform.sql show up right after browse. After we've done that, found the file to import, we need to scroll down to the bottom here, all the way down, and there is an import button at the very bottom of the screen. We'll click that. And I've got a bunch of check marks on my screen, so hopefully you get the same thing. That means that the file has been loaded appropriately. And another way to check this and make sure that you've got everything loaded in is that over on the left-hand side, where you have various different databases listed, you will see learning_platform as one of the databases listed. Let's do a quick pulse check just to make sure. Was everybody able to, I'm going to go ahead and start the pulse check. If you were able to load that in, can you go ahead and give me a thumbs up? That would be excellent. If not, I'll know to wait a little bit longer. Okay, looks like a good amount of you were able to go ahead and get that loaded. I'll talk a little bit about some other things. If you're still working on it, you've got some time. I'll fill some space here and talk about a few things first, and then we'll dive into some queries. Okay. All right, so within this PHP MyAdmin, there's lots and lots of different things you can do with this. We're not going to be using a ton of the features because really we just want to write SQL queries today, but there are lots and lots of things you could do with this if you wanted to play around with things a little bit. One thing you definitely will want to do before we start writing any queries, we basically have to let PHP MyAdmin know which database we want to work with. So if you were coding in, just MySQL directly through, let's say, your terminal, you would say use learning_platform, right? So let it know which database you wanted to use. The way that we do that with this GUI is actually we just click on the learning platform over on the left-hand side. We can just click on that. So you're clicking on this learning_platform. That basically is telling PHP MyAdmin which database you'd like to work with. And you'll know that you did that correctly and everything is all set up because up at the very top, you'll be able to see that you are working in the learning platform database. So you have that gray bar going along the very top. It'll say your server is your local host, and then your database is your learning_platform. It's basically just, again, telling this platform which database you'd like to work with. We're going to work with the learning platform. And you can see there's lots and lots of different tables in here. I created this database myself, and it's basically just supposed to replicate a company that has a learning platform, like let's say some kind of learning courses just like this one, but maybe something that's more on demand. So people are watching videos and we're recording how many minutes people have watched. Or they're submitting payments in order to be a member of our subscription service, of our learning platform. And so we'll see that we have various different users in here. We have a table for users. We have a table for the lessons that we currently offer, the courses that those lessons belong to, and lots of different things, the payments and lesson activity, how much time people have spent in each lesson. So lots and lots of things to explore with this database, and you're welcome to continue using this if you'd like to explore other questions and practice on it. It is a full full database for you to be able to explore things. So with the PHP-MyAdmin, if you ever want to just take a peek at what a table looks like, you can just click on that table name over in the left-hand panel. So let's say the users. We're going to just take a peek at that. If I click on users, you should be able to see how many, your rows here. Eventually, maybe it would truncate. I'm not sure. None of these tables are very big, actually, because I wanted us to have something that would run quickly during a live session. But you should be able to see at least a snippet here of all the different rows that you have in this table. And you've got, you do have the ability to edit these rows directly. If you made a mistake when you're typing, you can edit these things or delete a row or those kind of things. We're not going to spend any time on that because this is SQL for data analysis. We're just going to be reading from these tables and doing some computations as opposed to doing any sort of transactional SQL work. But yeah, so you can definitely, oh, so here it is. It tells you how many rows you'd like to do more rows, see more rows you can. We're just, all these tables that I'm going to show you are pretty small, so you won't really have to worry about that too much. But you can take a peek at any of them if you'd like. Here's the payments table. Switch over to that one. You can see the first 25 rows of that payments table. So you have access to be able to do that. You also have access, of course, to write SQL queries. That's what we're going to be mostly doing throughout this session. So I'm going to go back up to, if you see the tabs along the top, right now we're in Browse. We're just kind of browsing around the different tables. There's also Structure and then SQL. That's the one that we're going to be spending most of our time on today. So let's go ahead and click that. Okay. So it has some kind of generic query that is just pre-populated here. Let me give you a little bit of introduction of how this works, and then we'll write our very first queries. You can basically just type directly into this white box. Makes sense. Just put your SQL code in there. That would be fine. What I sometimes like to do, some of these buttons along the bottom, you can ask it to kind of pre-populate queries for you. Like, I'm going to write a select query. Can you kind of give me a few keywords that go along with that? I don't tend to do that very much. I tend to write my own queries. But one button I do find very, very helpful here is clear. And so that's kind of along the bottom there, almost toward the end of that row. We have a clear button, which can clear out the entire area. I think that one's really, really helpful. You don't have to press backspace a ton. You can just hit clear. So let's go ahead and write our very first query here. And again, we should definitely be saying, so our database is learning underscore platform. If it doesn't say that, you're going to get an error, but you'll just want to make sure that you click on that learning platform link, and that'll make sure that you're using that database. Okay. All right, so our very first one, let's go ahead and just grab the first 5 rows of the users table. So I'm going to select everything from users. And I'm going to go ahead and just limit that down to the first 5 rows. So once I have a query that I like and I want to go ahead and run it, I'm actually going to scroll down. There is a Go button at the bottom. We're going to click that. Okay. So this will show the results. We have these 5 rows here. We just get 5 because we did limit 5. And these are all coming from the users table. I have every column because I did select star. So one thing that, again, this is a pretty cool platform. You can export these. You can do all kinds of different things with it. You can save these queries. There's lots and lots of stuff you can do. We're not going to really do any of that. We're just using this to be able to query the database that we have set up. But yeah, you can definitely explore this more if you'd like. I'm going to go back to the query box. So we can click Show Query Box, and that'll just expand back out our query box so we can add more queries here. All right, so the next one, if you noticed, there was a marketing source column. So if you don't remember that, you can also expand out these tables. So if I click on, there we go. If I'm over on the users table on the left-hand side, and I just expanded this out, I clicked on the plus button, and then I clicked on the plus button from the columns, then I can see what all those column names are. Sometimes that's really helpful. There is a column called marketing source. And so what we're going to do now is try to find all the people that have come to us, that have visited our learning platform and signed up by utilizing Google. So maybe they've searched for some kind of learning platform and we've shown up in the search results. So I'm still selecting everything from users, but now I'm going to use a where clause. Marketing source is equal to Google. Okay. By the way, all these first queries are just absolutely warm-up queries. Sorry about the no processing. Let's go down and just run that. Sometimes I'll get, warnings that it's fine. Just go ahead and click go. It's fine. By the way, these are all just warm-up queries. I'd expect all of you to know, select and where and those kind of simple things at the, from the very beginning. And then we're going to dive into more advanced queries very shortly. Okay. But just to give you a sense of kind of what's in this data set, we do have, what is that, about six rows? 6 rows that are all people that came from Google. And you'll start to see some of the issues with this data set already as well. We definitely have some capitalization things going on here. Sometimes it's Google with a capital G, sometimes lowercase. And so now, MySQL in general is not going to be case sensitive at all. SQL typically is not. And that goes for the code that you're writing as well as searching against a particular word. Like we're looking for Google here, capital G or lowercase g doesn't matter. We will see some other things that do matter. And if you ever want to be super careful just in case, I'll show you how to do some lowercase and uppercase kind of things as well. All right, let's go ahead and go back and see how many people we have in this entire data set. So if I'd like to know how many rows are in the users table, what I can basically do is just say, instead of I want all of the columns, I actually want to count all of the rows. So I'll do that with a count star. And it turns out we only have 15 users in this data set. I think we already knew that by exploring the users table, but just to remind you, it's a really small data set just so that our queries will process faster. You could, of course, have thousands or millions of different users, if you're using this at work, right? Okay. Last little kind of warm-up thing we're going to do, and I'll give you a couple of exercises to make sure that you're warmed up too. Let's go back here. Let's figure out how many users we have from each marketing source. So we saw before that we had people from Google. What are the other marketing sources and how many people do we have from each? Okay, so let me go ahead and clear. So if I want to clear everything out, I could just hit the clear button. That's really helpful. Okay, so if I want to know how many people came from each marketing source, I'm probably going to end up with a group by. All right. So let's say I'm going to select. In this case, I want to select the marketing source. That's what we're going to be grouping by. And I want to know how many people came from each marketing source. So I'm probably going to count how many rows I have once I group everything up into marketing source. So we're going to do count star as num users. You can, of course, alias that however you'd like. I'm going to count them up and alias them num users. And we're doing all this from the users table. And again, our kind of whole goal here is to find out how many people we have from each marketing source. So we're going to do a group by marketing source. So group by the marketing source, and then give me that marketing source as one of the columns. Give me the count of how many rows you had for each marketing source as the other column. Let's run that one. Okay. So in our results, the way we're reading this is the first row I have says null. So there are a couple people in here where we don't have a marketing source. We just don't know how they arrived at our site. Maybe they went directly, or maybe attribution got lost along the way somehow. So anyway, there are 2 people that we just don't know. We have 6 people coming to us from Google. That's the next row down. We have 5 people from LinkedIn and 2 people came from Instagram. All right, so those things, those selects, where clauses, and as well as group bys, I would expect you would have seen at this point. So that's kind of our base that we're starting at. So let me give you a couple of exercises just so you can try out the platform and kind of just see how all of this works. So your first exercise, I'm going to put these in the chat as well. Your first exercise is to write a query to filter down to users from the United States. So let me put that one in the chat. And once you've got that one going, write a query to count the number of users from each country. So I'll give you some time to work on those. And by the way, for that very first query, you don't have to worry about any data cleaning things yet. You can literally just say who says they're from, the full 2 words, United States, both words. Okay, in the interest of time, since these were our warm-up queries, let's go ahead and discuss the answers for these 2 questions. There wasn't very much time. I promise I'll give you more time next time, but for now, let's move into the answers. So the first question was, write a query to filter down to users from the United States. So we basically and so I said, don't worry about data cleaning for now. If you looked at the users table again, you'll see that there's people from all kinds of they've abbreviated things differently and so on. Don't worry about that just yet. So we'd like to just select all the columns from the users table. And if we just want to focus in on people from the United States, if we're filtering, that's prime time for a where clause, right? So we're going to say where the country is equal to United States. All right, great. So it looks like there are 3 people from the United States based on that query. So all 3 of these people have United States as 2 words. But let's go back up and kind of double check things by counting how many people we have from each country. This query is going to look kind of similar to what we had before when we were doing things by marketing source. We're going to select, now this time, we're doing things, and by the way, you can build your queries. They don't have to be one line and then the next and so on. You can kind of skip to a line that you do know and then go back and fill things in. That's totally fine. So I know I'm going to select things from the users table. And since I'm concerned with the number of people from each country, it sounds like I'm going to be grouping by the country. Right? So if you know those kind of things first, that's fine. You can jump down to those and then go back and fill in which columns you want. So for the columns, I'm going to pick up country as one of my columns. And I'm also going to do a count because I want to know how many people I have from each country. So this is going to look exactly the same as the one that we just did in class here. Count star, we're counting the number of rows associated with each country. Now let's call that, we can call it again num users, or you can give it whatever alias you'd like there. Okay. All right, let's go on down and run that query. And so here is our issue. Here's our big lead into why we should do some data cleaning on this data set. We do have 3 people from United States, the full 2 words, but we also have 2 people from US. And if we look down a little bit further, we have another person from USA. We have someone from United States lowercase, which you'd think that would have paired up with the one above. But if you look really closely, there's a tiny space in front of the United States. And so spaces do not, collapse. So it may be case insensitive, but spaces can definitely throw things off. And I think that's also what's happening with our last row that also says USA. I believe there's a space in either the first one or the last one that we have there. Yeah, so we definitely need to do some data cleaning in order to answer this question appropriately. And so that's one of the things. We're going to come back to this problem again, trying to count up how many people we have from each country. But it turns out we definitely need to do some data cleaning first. Okay, so let's go ahead and do that now. Okay, so we're going to move into our data cleaning section. And this, we're going to cover the gamut. We're going to talk about cleaning strings and date times and all kinds of different things, casting, all these sort of things. So lots and lots of good stuff coming up in this section. So first of all, the very first thing you might want to think about is missing data. We already saw it. This data set definitely has missing data. We saw a few nulls pop up for marketing source. There were some nulls for the country, lots of different missing data. So here's a small example of pizza data. This is, what location sells what kinds of pizza, and then what price are they selling that at. This for a slice of their specialty pizza. But there are definitely some places here that are missing. We see that Little Oven specializes in cheese pizza, but we don't know how much they charge for that. But beyond just absolute blanks, that you could have. So that's one thing. You could just absolutely see a blank, and that would be your missing value. And SQL would write that as null if you have a missing. You can also have missings like question marks, where people have filled in some kind of character, maybe NA or maybe question mark, meaning that we don't know. That's basically the same thing as a missing value. It's just that a human has filled in a question mark, and SQL won't necessarily interpret that as a null unless we ask it to. So that's also possible, these filler values that actually do mean missing. So it turns out we have to treat these a little bit differently. The very first one, if we're looking for actual blanks, we can use the keywords in SQL is null. So it turns out we can't directly compare against the keyword null. Like we can't say equals null. That doesn't work. Null is more of an idea or a concept as opposed to a specific value. So that won't work. We have to use the keywords is null when we're looking for missing values in SQL. And it turns out if we do have these filler values, what we should really be using instead is, what we should really be doing is converting them to nulls. So we use this function called null if. That will help us convert these question marks or -1. Sometimes I see that as well. We can convert those into missings and then proceed to treat them like nulls. As far as like how to handle those once we even find them, so that was just finding missing values. Now if we're going to actually like handle those missing values, we're going to need to do some different things as well. So there's multiple ways. One way is just to leave them there, and that's the way that honestly I probably do the most work when I'm doing data analysis in SQL. Most of the time, I just leave those missing values right where they are, because a lot of the SQL functions that we'll talk about, averaging or those kinds of things, they can just deal with not having a missing value. They'll just skip over that value and they'll compute an appropriate average for the values that you have remaining. Okay, so that's probably honestly the one I use the most, but there are definitely cases where leaving the missing values doesn't necessarily work. Another option is to drop your missing data. So if you've got rows that have very, very little information in them, the entire rows are basically blank, or if you've got rows that have blanks in places that really should be filled in, right? Like maybe one column is really, really important. You may decide to just completely drop rows that have missing values in that particular column. Okay, so that's another strategy. You can also do something called imputing. And imputing is basically, we are going to try to fill in that missing value with something that makes sense. So one way is, let's say in that specialty column, we have a missing value for the slice. We don't know what their specialty is. Well, we might say, well, the mode or the most common answer from other pizza places is cheese. So probably if we don't know their specialty, they probably do sell cheese pizza, right? We could maybe say, I'm going to go with the most common response for that particular column and just fill in cheese. And you can see how that could definitely be dangerous in some situations. Some situations you don't want to be filling in values if you don't know the answer, right? But sometimes it can be appropriate. So that's called imputing, that we're actually just filling in some kind of most common value. Or the other way that people talk about imputing, over on the price column, a really popular way that people work with missing value for numerical data is to fill in with an average or with a median. That's another popular way to impute missing values. So all these strategies can be valid. Leaving the missings or dropping them or imputing them can all be valid in certain situations, but it definitely depends on that situation. It really, really does. It depends on what you're going to try to do with the data. Depends on, here's my big pro tip here, depends on why that data is missing in the first place. So determining why the data is missing will help you develop an appropriate strategy for either leaving those missing values or dropping them or so on. If you can figure out why those missing values exist, then it can help you come up with an effective strategy. For example, I used to work with this housing data set, and there was one column called garage. And it was basically how many cars fit in a garage that goes along with this house. Okay, so sometimes it would be a 1-car garage, 2-car garage, 3-car garage, and so on. So it was like an integer number. And it turned out that when people had created that data set, there were a lot of missing values in the garage column. It turned out that that meant that the people just didn't have a garage. So if we're actually trying to say, on average, how many cars can be in a garage structure for these houses, it may be appropriate there to fill in that column with zeros. If you don't have a garage, you can't put any cars in the garage, right? So in that case, maybe filling with 0 made the most sense. or excluding those if we just want to talk about structures that do have garages. Anyway, so trying to figure out why those are missing and how you're going to actually use the data going forward is a really important step in handling missing values. By the way, I should have mentioned from the very beginning, if you do have a question for me, you're absolutely welcome to pop that in the Q&A if you'd like, or the chat if you want everyone to see your question, and I'll be monitoring those throughout. I'll also take some time specifically toward the ends of each of these sections to ask if there are any questions, if there's anything we should address. All right. So that's my spiel on missing data. The next thing that you might want to do when you are data cleaning is converting between data types. Now, it may not seem that important off first bat, like, you know, if I have integer values and I have floating point numbers, why would I need to convert between them? But there will definitely be cases where you'll want to make sure that you're matching data types up correctly in order to achieve successful outcomes. For example, I feel like one of the most common times that I end up changing data types is if I need to join two tables and the common value in those tables happens to be stored as one data type in one of the tables versus another data type in the other table. You try to join them and you have definitely some issues with that. So it can happen that you'll need to change your data types as you're working with your data. Okay, so the way that we do that in SQL is with something called cast. Cast is going to allow you to convert from one data type to another. And here's how it works, pretty simple. So if I wanted to convert the floating point number 13.75, the decimal, into an integer, I could write select cast, I'm using parentheses, the value that I want to cast, then as, and then the data type I'd like to put that into. So we use the cast keyword there, the function. We use the expression that we'd like to cast. We have the word as, and then we have the data type that we're converting into, the new data type for our expression. Okay, so that when I say expression, that could be an actual numerical value or a text value there, or it could be a column of information. That would also work. The result here is actually 13. If you guessed 14, you're not alone. A lot of people might think that 13.75 would get rounded up to 14. It turns out if you're trying to cast decimals into integers, you're probably going to be just lopping off the decimal and doing kind of a floor division there. You're going down to the nearest integer. Keep that in mind as well. Okay. I'm going to go ahead and move into a coding demonstration so we can take a look at how to do the missings and how to do the casting back in our PHP-MyAdmin, the GUI. So let me go back over to that. So that's where we left off. We had just done one of the exercises, but now we're going to do some data cleaning. And for this section, I'm just going to demonstrate a few of these techniques actually on our data here. Let's go ahead and look at the subscriptions table for this one. So I'm going to clear everything out and let's just take a look. You can either click on the subscriptions table if you'd like to see it, or maybe you want to do select all from subscriptions. Sorry, it doesn't like my semicolons. I'm so used to doing them. This platform doesn't particularly like them, so. All right, so here's what the subscriptions table looks like. Basically, what we're seeing here is we have a subscription ID, we have the user ID, and those correspond to all of the emails we were looking at before, all of the countries, and so on. Then we have the plan name. Which plan, which subscription plan did this person sign up for? When does that plan start? And then when did it eventually end? When did they cancel their subscription? So you'll see that some of these users signed up for one type of platform. This number, for example, in the second row, this person signed up for our premium subscription, and then changed, I think that's a downgrade, to our Pro subscription. No, they upgraded, excuse me, Premium and then Pro. You can see by the prices here. They upgraded to the Pro subscription in June. Okay, so sometimes people change which subscription plan they're on. Sometimes people cancel and then come back, or so on. Sometimes people start with a trial and then they actually sign up for a subscription. So this is the table that we're going to be working with. I'm going to go back over to my SQL window here. Let's go ahead and try to find all of the people where the end date is missing. So if you notice, when we have start dates for everyone, we also have end dates. So end dates being missing in this case means that the user is still on that subscription. So let's go ahead and try to find all those people. So we're going to be selecting everything from subscriptions table. Now we're trying to find everybody where the end date is missing. So that sounds like I'm going to filter, right? I'll do where for my filter. I'm thinking about the end date. And by the way, this platform has tab complete. If you've noticed, I've been kind of tab completing some of that. So it is helpful to kind of speed up your code a little bit. It has the tab complete option. So if you're brand new to dealing with missing values, you might think, hey, I can just put equals null. I'm looking for all the places where end date equals null. So you could try that. This one actually won't give you an error. It actually just gives you nothing. So 0 rows. We know that's not true. We just looked at the table. We know that there are people that had missing values in the end date. So what's happening? This is what I was talking about when we were doing the slides. The end date cannot be equal to null. Null is not something you can be equal to. It's a concept. It's missingness, right? It's not 0. It's not a blank string, nothing like that. It is a concept, and you can't be equal to it. The way that I should write this query instead is not equals null, but is null. I need to write is right there in order for this query to process as I'd like it to. All right, so there's all the people that have no end date, which in this context means that they are still on this plan. Whatever plan they have signed up for, that's the one that they're currently still on. So these were all of our active subscriptions. And that could definitely be helpful for our analysis. Maybe we want to just find out something about our active users. We could filter down to them and then go on to do more computations based on this data. Or maybe we want to find all of the people that are no longer active, that are not active anymore. So for that, we would need one more keyword here. So right now we have where end date is null. If we want people that do have a value there, that have closed their accounts, we could write is not null. And that should now give us all the rows from that table where we do actually have an end date, where that subscription has been canceled. Okay, so is null or is not null, both are very helpful when you're working with filtering or doing those kind of things. But one thing to keep in mind as you are dealing with missing values, again, like I said during the slides, I mean, the way I most often deal with missing values is to just leave them alone, just leave them there. And by that, I mean that, I'm gonna go ahead and clear this out. A lot of the functions that you probably already know and love do still work with missing values. So let's go ahead and select. We're going to go from that subscriptions table. And let's go ahead and select the minimum end date and also the maximum end date. So we know that end date has missing values. These functions will still work despite the fact that we have missing values. Let's go ahead and run that. So we were able to get the minimum date. The very first person signed up, the first time that we had somebody sign up, it was on January 31st of 2024. the maximum end date, the last time that somebody canceled their subscription was on June 30th, 2025. Okay? So you can still use a lot of these numerical sort of functions that you already know about, even if you have missing values. SQL will basically just pretend like those missing values are not there and give you the minimum or maximum of the ones that do exist. Okay, so let's go back and take a look at subscriptions one more time. Here we go. Let's say that we wanted to round these prices to some value. Okay, so right now we have, maybe we want to round them so they don't have any decimal places anymore. Round them to the nearest integer dollar, something like that. Let's go ahead and try to do that. Okay, so I'm going to select from the subscriptions table again. And I want to get the prices, but I want to round them to the nearest dollar. So I could use a function called round. I would put in which column I want to round, and the next number is how many decimal places do I want that value to have. You could also do negative numbers if you want to go beyond the decimal, if you want to round to like tens or hundreds. But I'm just going to say 0 so I can round off to a dollar amount. Okay, let's call that as rounded price. Okay, all right, let's try this. Okay, so that actually works. This actually worked pretty well, right? We had $10 for all the $9.99s, $20 for the $19.99s, and so on. So that seems to work. Let's see if we can get it to round to the nearest 1, the nearest 10th place. So let's change that round to 1 instead of 0. Okay. We actually aren't getting a 10th place here. We're still getting 10, 20, 30, and so on. We're not getting a 10th place because price is actually a varchar. So if we, I think if we look into subscriptions, and I think you can do like this, yeah. So if we look over at our subscriptions, and we look down into the columns, kind of investigate the columns. If you look at price, it's not actually decimal data type. It is a varchar instead. Okay? So it's just a text data type. So someone has, when they were creating, I'm blaming it on some random fictitious person when I know full and well I'm the one that created this data set. Someone has created this data set and made price a text value instead of a numerical value. And a lot of times your RDBMS, your MySQL or your SQLite or whatever you're using can compensate for those things. It can still do a lot of the numerical functions on these text columns because it will recognize that it'll help you on the back end. It'll recognize that you actually have numbers. It'll convert everything into numbers, then do the functions, then return some nice normal results. But that's super dangerous, right? It can be really tricky and it doesn't always work the way that you think it should, right? So sometimes your RDBMS is forgiving, sometimes it is not. So we definitely want to be careful when we're dealing with data types that don't actually match the data that we have. This price should definitely be a decimal or value instead of a varchar, right? So what we can do is cast that column first before applying our function. So let's go back up to our query. So now instead of just directly rounding the price, I'm actually going to make an extra line for us so we can see what's going on. What I'm going to do, instead of just having price there, I'm going to cast price as a decimal 6-2, meaning 6 digits, 2 of which come after the decimal place. So it could be it could be $1,000 subscription. It's probably not, but I'm giving a little extra room there and have 2 decimals afterwards. I still have the (1) here, and this is saying that I want to round that to the nearest 10th place. But I've casted the price column to a decimal. Oops. Which one did I do here? I lost one of my parentheses. There we go. Try it again. There we go. All right. Lost a parenthesis. Sorry, it happens. Now we're actually seeing the rounding exactly as we imagined, that we have 10.0, right, 20.0, and so on. And that's just because, you know, we thought we had numerical values, but we actually had text values, right? So that can be definitely a problem. Another place that you'll definitely see problem here that you'll often need to cast things is with dates. And that leads me to our next section. We're going to be dealing with dates next. But yeah, that's another place that you might see cast a lot. Okay. All right, so I'm going to hop back into the slides so that we can do some dates. But let me go ahead and check and see if we've got any questions as we are looking here. Yeah, we had a question here. Are we going to be doing operations that can be performed on 2 or more tables, like maybe connecting them together by a key or combining them and so on? I think you mean, like, are we going to be putting tables together? And yes, that's our next section after the data cleaning. Yeah, we're going to finish up the data cleaning, and then we're going to be moving into joining and unioning and those kind of things. Yes. All right. Okay. So let's pop that back into a little bit more slides, a little bit more to do with dates, times, and some string functions, and then we'll move on. Okay. So let's manipulate some strings. So let me tell you, strings can be really, really tricky. Strings can be really, really tricky because I feel like the issues that you see with strings can be like silent issues. For example, spaces. Sometimes you may not be able to see extra spaces on one side or the other. So I have a really hard time dealing with strings sometimes in my work. And there are definitely some functions that can make things more simple, but string manipulation can go in lots of different ways. So I'm actually going to present to you, I believe it's the top 3 that I come across most often, but there are obviously more and more issues that you might have with strings. We had one more question just before I dive into this. For developers who work with databases in the cloud, how can they connect and work with databases? For example, when we don't have this PHP-MyAdmin. So yeah, there's like I could do a whole other course about how to connect to things in the cloud. It comes down to the connecting to other databases in the clouds and things can be a little bit challenging. It depends on kind of how your company has set everything up, whether they're using software as a service or infrastructure as a service, like what type of cloud they're using. So getting everything set up can be painful depending on what system you're using. However, once you get everything set up, using SQL code should proceed exactly like normal. Like the things I'm showing you today should work on cloud data just as well as it works on PHP-MyAdmin, right? Especially like, let's say you're doing some kind of software as a service, you're using like Snowflake or something like that. Those kind of things, you will just log in and submit your SQL code just like we're doing right here. So it can vary a lot depending on kind of what cloud provider you're using or like how to make those connections and so on. But the actual SQL you use to interact with the data is going to look, if not exactly the same, really, really similar to what we're discussing today. So that's good. Okay. All right, so let's take a look here a little bit about strings. Here's some of the issues that you can see. And again, these are just a couple of issues, but here are some of them. This is my name, Dr. Kim, right? This is my company, Dr. Kim Data, right? So Dr. Kim, here's my name, but it's written lots of different ways. And so maybe this is me teaching 3 different courses. This is all the same instructor. But due to some random text issues, if I tried to group all of these together, I would get 3 different instructors. I wouldn't be able to group this person together because we have some string issues. So these are the top 3 data cleaning issues I see for strings. One, that you have junk characters. So Yeah, no offense to these characters, but they can cause a lot of problems. In this case, it's all the extra periods that are kind of hanging out. I have some periods after doctor. I have a period after Kim in one case. It may be periods, it may be tildes or ampersands or any kind of thing like that, but there could be lots of extra junk characters that you just don't want. You may also have the situation, and this one happens maybe even more so, that you have white space on the edges of your text. So you can definitely see in the very first one there, I have space Dr. Kim. That's going to cause a problem when we try to group things together in SQL because those spaces will be treated like entirely different strings. And the last one, which is maybe less so of a problem in SQL, is that our case is not standardized. So is it going to cause a problem that I have some capital K's for Kim and some like lowercase d's and some capital? Is that going to cause a problem? SQL's probably going to be pretty forgiving on there, but if you are exporting this to something else, other languages, let's say you're going to work on it in Python next, Python is definitely case sensitive. So it depends kind of what you need to do with the data. You may decide to standardize the case within SQL so that when you export data or so that when you pipe it to something else, everything's nice and normal. All right, so let's talk about how to deal with each of these three. First, removing the junk characters. So that's going to be dealt with a function called replace. So here's how replace works. We have the replace function. We will pass in a column name, or this could even be just a single text if you just have one text you want to clean up, but probably it's going to be a column of text that you're dealing with. What we should be finding, so in this case we want to find all those periods, and what we want to replace those with. Now, the most common way that I use replace is to basically remove characters. So what I replace that character with is an empty string. Basically says every time you find a period, get rid of it. So this is a really, really common way to be using replace, is to replace things with empty strings. All right, so if I pass in the instructor's name column, just as it says here, what would happen? I would be able to remove all of the periods using replace. So that's the very first really common function that you're going to use when you're manipulating strings in SQL. The other one is to get rid of the white spaces. That's going to be with a function called trim. So I'm actually building this one. I'm going to be building upon each of these. And this is the nice thing too, you can combine all of these functions together. But trim could act on its own. You could just trim the name column and that would take away the outside spaces. Or you can trim the results of the replace, which is what we're going to do here. So you have the trim function and basically which column or expression that you want to remove white space from the edges only. So if I did trim and replace on this column, I would get rid of the periods and I would get rid of the white spaces on the edges only. So I still have a space between Dr. and Kim and all of these texts, but I don't have an initial space on one end or any spaces on the other end. Both of those are gone. It also doesn't matter how many spaces you have on the ends, it would get rid of all of those. So if you had 5 spaces on one side or however it's going to be, those will all be removed. All right, so replace was our first one, trim is our second one. Our final one here is, oh, I guess I forgot to change the title there, but it should be lower, right? Our final one, to standardize the case, we're going to use lower as another function here. So again, I'm just wrapping that around the results of replace and trim, but it could be used on its own. Lower converts everything to lowercase. So we would start with our messy name column. We would use replace to get rid of all of the periods, trim to get rid of all of the extra white space, and then lower to make everything lowercase. And so you can see with the combination of all three of these, I now have Dr. Kim written out in the exact same way for all three. I could do a group by on this column or whatever I need to do, and those would all be treated like the exact same string. So three super, super helpful functions. Why did I pick lower instead of upper? It doesn't matter. You could do upper if you like. Sometimes I don't like it to look like it's shouting at me. The upper makes me feel like, all capital letters, right? So I often do lowercase, but you can absolutely do upper. That's totally fine. Okay. All right, that's our string manipulation. We just talked about, sorry that they're, all the numbering has switched over to all ones. Sorry about that. But we have three different things we just talked about here. The removing the junk characters with replace, trimming the white space with trim, and standardizing the case with lower or upper, whichever one you choose. That's dealing with strings. You'll often also have to work with dates, and that comes with its own set of functions. So I just want to address a couple of points here with dates, because yeah, that can also be a whole course into itself. So we'll just do a couple of things with dates, and you know that you can do a lot of other things too. For dates, there are 4 different common techniques to tell you about. First one is a lot of times you'll have a string column, a column of strings that should actually be dates. Like somebody has written 2024-01-01, but as a text instead of, and they've saved it as text instead of saving it as a date column. So that's one of the most common things we have to do is convert from strings into dates. You may also have to extract date parts. So I end up doing this a lot too. If you do have a date column, you should be able to then extract out the year or the month or the day or so on. So I'll tell you how to do that as well. You may also need to do date arithmetic. Like I have a bunch of dates. What do those dates look like a month from now? Or can I project those forward a week? Or can I what happened like a year ago? Maybe I can subtract off a year. So I think you may need to add or subtract date components. Or we may need to, now this is kind of the converse of the first point, convert the dates to a string format. So this one can get really out there, right? Depending on kind of what string format you need. If you do have date time, sort of a date time column, you can print out the month, like written out like a nice word instead of just a number. You can do commas wherever you need them. You can do colons for hours and minutes. There's lots and lots of different things you can do. So we won't go too in depth with that, but really you can get it print out to a string however you'd like with these. The first one I actually already know about. If you need to take strings and convert them to dates, just use cast. I'll show you in the demonstration too, but that one's easy. Just use cast. Extracting, and one other thing I should definitely say, dates especially, really the whole session, but definitely dates. The syntax can definitely vary across RDBMSs. I haven't said so explicitly yet, but as you may have noticed, the PHP MyAdmin is MySQL. That's the RDBMS we're using on the back end. So sometimes the syntax or the actual code you use to execute these things can vary depending on what RDBMS you're using. If you're using MySQL versus SQL Server or maybe PostgreSQL, all of those are going to have slightly different variations, and I especially notice different variations when we're talking about date functions. So definitely consult if you typically use a different RDBMS on the back end. You may need to end up with slightly different functions, but you'll probably be able to find a function that does do the things that we're talking about here. Okay. The second one, extracting date parts, all we need to use here is something called extract. So here's how it works. We use extract. We say the type, the unit of time that we need. So for example, a year or a month or a day. you'll say from, and then the column that you need to get that information from. So extract is really useful and simple. Again, this is a MySQL function, but you'd have a similar function, depending on your RDBMS. It's really, really useful. One thing that this is built on that you would have to have first, that date column needs to actually be a date column. And so if you had a bunch of strings in there where someone has just, happened to write the dates, you'd have to convert those to dates first before you could use extract. If we need to do date arithmetic, really it's just a matter of using plus or minus along with a keyword interval, right? So you'd have your column of dates. You could use plus or minus, your math symbol. Then you'd use the keyword interval, and then the amount of time that you want to add or subtract. If we need to convert dates to string formats, we're going to use something called date format. We'll use date format, the column that we need to format, and then finally we have our date format string. So again, I won't go into this too much, but if you're not familiar with what these strings look like, you would definitely want to spend some time kind of getting familiar with them. Basically, this one in particular, this month, day, year format is really popular here in the US. Percent lowercase m gives us the month. Forward slash, we'll actually see a forward slash in the string. Percent d is lowercase d is going to give us the day, forward slash, and then percent capital Y gives us the year, a 4-digit year. So whether these are capital or lowercase can change the meaning, and you definitely want to spend some time. These are pretty standard across other programming languages as well. You'd want to look up date format strings to get the exact way you want to format these. Okay. All right, so we'll recap that quickly, and then we'll try to do a couple examples here. So working with dates, there are 4 common things that you want to do with dates. First one is converting strings to the date type. That's just cast. We already know that one. Extracting the date parts. That's with extract. I try to clue you in here. Extract the date part. I even use the word in what it's called. So extract is the keyword you'd use there. Doing date arithmetic, we're going to need to use interval. And then converting dates to string formats would be date underscore format. Okay. All right, let's see these in action. I'll jump back over to sharing my screen. Okay. All right, so let's go ahead and we're still working with subscriptions table, I believe. Let me see here. No, we're going to go back to the users table. All right, so if we take a look at the users table, that is going to be this one. So here's our users table. We know we have some issues with the country. We'll come back to those a little bit. But we also have some issues with the email addresses, okay? So the email addresses also have some problems. Some of these characters are just not allowed. For example, the tilde is typically not allowed for emails. So we're going to get rid of those, especially not in a domain, but we're just going to get rid of all of them in this case. And we also have some problems with white spaces. Maybe you can see for this person, it's slightly spaced over. So we're going to try to get rid of those as well. So let's go back over to our SQL tab and clear that out. All right, there we go. Okay, so first thing we're going to do is try to get rid of the tildes in all of those emails. So we're selecting, and it's going to be from the users table. We're going to replace. So now replace, remember, starts with the column that you'd like to replace something with. Okay, this is how the syntax works. We're focused on the email column, so that goes first. The next thing that we put after that comma there is what we're trying to get rid of. In this case, we're going to try to get rid of tildes. So those both go in, that goes in single quotes, just like any string in, sorry about the error processing request. It keeps doing that, but everything's good. We're all fine. It's just, I'm kind of pausing. So it's like, oh, maybe you're not actually logged in. No, I am. Sorry about those. We're trying to replace from the email column, we're getting rid of the tildes. That should be in single quotes because that's a text. And we'd like to replace that with nothing, right? So we're basically just going to have a blank there. So we're going to use the single quotes around that as well. We're going to replace it with nothing. All right. Hoping it loads. I may have to refresh everything. Let's see. Okay, let me try to. All right, I'm just going to refresh everything again. By the way, as you'll see, if you do end up needing to refresh this, I'm probably also going to need to load that file, the SQL file back in. So if this happens to you, that's okay. We can just load everything back in. Okay. Right, so I had to refresh everything. The connection got lost. If you take a look over the left-hand side, I no longer have learning_platform as one of my databases. I just have to reload that file in, so I'll do that now. And I went over the SQL tab, but maybe a little too early because I need to make sure that I am using the learning platform database. So I actually have to click on that. And now I can go into SQL. It's just basically saying, hey, don't forget to use this database. Okay. All right, so I was trying to replace the tilde from the emails. And maybe I'll even call that email clean, something like that. Sorry. Well, there we go. Okay, all good. All right, all good. Oops, increase that some more. There we go. Okay, so what we've been able to do, if you remember this email right here, alex@example.com had a tilde in it. We were able to actually remove that tilde by using replace. The next thing that I said that we could do is get rid of white spaces. So all we're basically going to do is now wrap trim was our white space remover. We're going to wrap that around our replace. So obviously you could use trim by itself. You don't have to use it with replace. But a nice thing is you can kind of chain these string manipulation functions together. So I could trim the white space as well. Okay, great. And so again, if you remember this, alex@example.com had a space in the beginning. We've gotten rid of that. And the last thing we might want to do is make everything lowercase, potentially. And to do that, just like we had on the slides, we're actually going to just use the lower function. And now everything is lowercase. So it makes it look a lot nicer, right? The final, lowercase may not have been super necessary. SQL is typically case insensitive, but it does make everything look a lot nicer, especially if we were going to export this to some other language and start doing some data handling there. That one may be case sensitive. So this is another nice function to have in your toolbox. Okay. So I want to do a little bit of the date manipulation, but we are running a little bit shorter on time, so just do a couple of things here with the date functionality. and then we'll jump back into some other things. All right, so one thing I mentioned before, maybe I haven't mentioned it yet, if we go to the users and take a look at the columns, if we look at created at, that's supposed to be a date column, but it's also a varchar. So it's another one where someone has just put text in there instead of saying that it's a date column. So we'll definitely want to cast that column to be a date column. So let's go ahead and start working with that one. We're going to cast created at as date. So in order to use all of these date functions that we've been talking about, the extract or interval or any of these different ones, we actually need it to be a date column first before we can interact with it, right? So I could use cast on my date column. Let's say go. And there we go. So now we actually have a date column. Sorry, I didn't alias it, but these are actually in date format and they're no longer strings. So the nice thing is now I can add things to these. I can, whatever I want to, any kind of date functions I know about, I can use now. So for example, let's say that we want to get each person's email address along with the date that they, along with the year that they joined us, right? So I'm also going to get email addresses. I want to get the year from this new date column. So for that, I'm going to use extract. So extract year from cast created as date. And let's call that year. Okay. So I'll go ahead and run it in just a second, but just remember that, we had to cast it first before we used our extract. Okay, now we know what year each person joined us. Okay. All right, any questions about the dates or the strings, anything like that? We do have a couple of questions here. One of the first questions is a great one. Does the order of the lower, trim, and replace matter? Sometimes. And that's going to be one where you'll just have to logically think through what thing do I want to happen first? For example, replace and trim, I think, are the ones that really matter a lot. So let's say that I did trim first before replace. Well, if I had a tilde and then a space and then the person's email address, if I did trim first, nothing happens. Then I replace, I get rid of the tilde, and then I still have a space before the person's email address. So typically you'll want to do the replace first, then the trim, that from inside to out. The replace should happen first, then the trim, the lower. The way I kind of showed you is typically how you'll want to do that. But yeah, you'll definitely want to think through what's like the last thing I want to have happen and what's the first thing and so on. So yeah, typically replace first, then trim, then lower. Yeah. We've got another question. What if you cannot clean the data? So for example, clinical data that can't be changed. That's a really tricky one. Yeah, oh man, I don't know. One thing I guess to keep in mind, and I don't know, I don't work with clinical data myself personally, so I don't know what the rules are, but everything that we have done here, all of the lowercase, uppercase, so on, did not change the underlying data at all, right? If I go back to the users, if I go back and look at users again, I still have that tilde, right? I still have this space for the person's email address. It doesn't actually change the underlying data at all. I'm able to do the analyses by working with the data. I could put together my report here in SQL and not actually export it ever and not actually change the underlying data as well. So that might be something that you'd want to take a look at if it's okay to analytically work with the data but not actually touching the underlying data at all. A lot of times as analysts, we won't even have write privileges. We just have read privileges where you can only pull from the table but not actually make any changes. Yeah. So that'd be something I'd look into. All right. Okay, great. So I'm going to go ahead and stop sharing. And I think, so we're already at 11:30. This is a little earlier than I had planned as far as in terms of material, but I think we should go ahead and take a 5-minute break at this point. So go ahead and take a 5-minute break and we'll meet back here. Sorry, it's 11:30, whatever time zone you're on. We'll meet back here at 35 past whatever hour you're on. See you then. All right. Hi, everyone. Welcome back. Um, Before the break, we did a lot of data cleaning, and I have just one more data cleaning thing to show you before we move on to another section of the session. So far, we've done data cleaning for strings and for dates, and we looked for missing values. We did some of that. The final thing I wanted to tell you about, sometimes people don't classify this as data cleaning. I do because it is a technique I use for data cleaning, but you may have heard about it through other things, and it's the case expression. So how you might use a case expression for data cleaning is something like this. Say that we've got this is our pizza data that we are talking about before. We've got the various different locations and specialties and the prices. What if I wanted to bucket these restaurants or these pizza places into expensive places and not so expensive places? Could I do that? So let's do that. If I wanted to give this table an extra column called price range, this is something I don't know if I don't know. I call it data cleaning here, but it could also be data transformation. You could think about it like that. If you wanted to transform those prices into categories, one way you could do that is with the case expression. Okay, so here's what it looks like. There you go. Okay. Here, I'm just going to write it out and then we'll digest all the different pieces. This is what we could do to create that column that has dollar signs in it. So we would use select like normal. Then we would start our case expression with the keyword case. That's how all the case expressions start with, case. We would then say when the price is less than $3, so some kind of condition. So if this condition is met, then, you say then, what should happen? So in this case, we're just going to put a single dollar sign if the price of the slice, the specialty slice, is less than $3. You can go on then to have as many of those when then pairs as you'd like. So here's another one. You can have another one. Now, when the price is less than $4, then do $2 signs. Eventually, a lot of these case expressions will have what you should do if none of those conditions are met. So in this case, otherwise or else, put $3 signs. You'll always end your case expressions with, sorry, that's the final result for anything that's left over. You'll always end your case expressions with the end keyword, and you're going to want to give this an alias, otherwise you'll have a really long column name. So we'll give it an alias as well. Okay. This is kind of the breakdown of what a case expression looks like. It's basically a way for you to do an if-else conditional, or if-then-else conditional. And when you are creating these, basically data enters, you can think about data kind of funneling from the top down. We'll check the first condition for all of the different rows. If that first condition is met, that piece of data gets the single dollar sign, and we don't even check any of the other conditions, right? So think about it as a hierarchy. You're checking the first thing. If that's met, okay, good. Get that piece of data out of here. If that's not met, we need to trickle down to the second when then, or the third or the fourth or so on. So we kind of start from the top and then we work our way down. That's how this is structured. So if I had a slice that was priced $2, it would match all of those conditions. But because it matches the first one, we give it a single dollar and we don't even consider the other conditions. All right. When you are writing a case expression, you will always have So the required keywords that you always have to have are case. You have to have at least one when then pair, and you have to have the end at the end to know, so SQL knows it's over, right? Everything else is optional. You don't have to have two when, you can have just one, that's fine. You don't even have to have the else, okay? But those things are necessary. Case, when then, and then end. And eventually, because we follow that, we'll be able to create a column just like this one. All right, so let me go ahead and show you this in our data set that we've been working on. Okay, I'll go back over to the SQL tab and clear everything out. Okay. All right, so for this problem, let's work on something here that has to do with our learning platform. Let's say that they change their from a legacy system to a current system on June the 1st, 2024. And so this actually happens a lot at companies. Like you'll make a really big systematic change, and then management always wants to know, well, what happened? Was it better before or after? Did we get more users before in the legacy or after? Or those kind of things. So a lot of times you'll have like a particular date and time, and you want to compare what happened before or later, right? So they made a big change on June 1st, 2024. We're going to add a column to the users table to let us know if each person signed up under the legacy system or under the current system. Okay, so we're going to be doing select, of course. We always do select. We're going to be selecting, and we're going to be selecting from the users table, right? We're back in the users. In this case, let's get their email address. That's how we're going to identify them. I think they also have an ID number, but it doesn't mean a whole lot to us. We'll do their email address. Let's also get their created at date, since we're talking about dates here. But remember that created at isn't actually a date, right? So when we do our case that we're about to do, we're also going to be casting created at into a date in order to compare it. That's not entirely necessary. I'm being a little bit cautious here, but you know, sometimes systems would require that, so I'm going to do it here. Okay. So we're trying to label each user as signing up under the legacy system or under our current system. So we're going to use a case. I like to, when I am building a case, just go ahead and put the end, right? Before I even write what all the when-thens are, I want to make sure I don't skip that keyword, right? I've got to have a case, I got to have end. And I'm going to want to alias it because it's going to be a really long column name if I don't. So let's call this as platform, as in, is it our old platform or our new platform? And now I'll go back in here and put in my when-then pair. Okay, so the date that everything changed was June 1st, 2024. So when, and again, I'm casting, I don't really have to do that, but just to be mindful of created at is not a date currently. I'm going to cast that as a date. When created at is less than 2024, what did I say, June 06, 01. All right, so I'm entering year dash month dash day. That's the way SQL is going to want dates. Then I'm going to write legacy. Let me just move that over. For SQL doesn't care about white space. We usually care about white space so we can read everything, but SQL doesn't care. Okay. All right, so I could write this. Everybody who is who registered before June 1st, 2024 is considered legacy. I also want to know who's considered who's signed up on the current platform, right? So the way I'm going to do this is just anybody else, anybody who didn't sign up before June 1st, 2024, else, I'm just going to write current for that person. All right, so you're either legacy or you're current based on your created at date. All right, let's try to run that one. Okay, so we have some people are legacy, some people are current. That's great. We don't actually have this, but just to kind of put the bug in your ear here, like just start thinking about it. What if I had somebody and I didn't know their created at date? For some reason, that data was lost. I didn't know when they signed up. I just know we have them in our system. If I had a null in this created at column, the way my code currently works, well, is null less than 2024-0601? No, because null is not equal to or less than or any of those kind of things. So that wouldn't have matched. Else current, right? So if I don't have data for created at, if that's a null, this case just puts that person in the current bucket. And that may be what I want to do, but probably isn't what I want to do. So what I could do instead is actually check to see if that person has a null value, right? And I would probably add that as the first. It may not actually matter here, but I'd probably add it as the first thing I check for. So when created at is null, then null. I just want to leave that null alone if there is one. Okay? So that would be the very first thing this code would check. Is that value missing? If it's missing, this new platform column should also be missing. Otherwise, we're going to see if the person is legacy or current. That's just a nice way to like keep everything clean. And again, depends on your data. We didn't actually have any missing people here, but you may in your data set. All right. So that's case. This is a good point. If anybody has any questions about any of the string manipulation things that we've done so far, feel free to ask at this point. Okay. All right, otherwise we'll jump into the next section, finding and joining. Okay. All right. So this is going to mark, kind of a shift in what we're learning about here. We've done a lot of data cleaning. Now we're going to move on to finding and joining. So this is a totally different set of skills, all SQL still, but we're going to be talking about really different concepts at this point. Okay. All right, the first thing we're going to talk about here is how to query a query. Okay, so I feel like this kind of marks the point in the session today where your power just grows, right? Your SQL power is growing and growing at this point. Data cleaning, okay, we got it, we handled it. But being able to query a query or join things together or, write these window functions, these sort of things, this is really just what's taking to the next level. Okay, so let's learn how to query a query. Okay, let's say I have these pizza prices again. And what if I'm asked, which place sells a pizza slice for less than average? Okay, I mean, it sounds like a simple question, right? But when it comes to like actually executing that in SQL, it takes a minute, right? It turns out that, okay, I could do select everything from pizza, and then I go to write my where clause, right? I need a where clause, but price has to be less than what? So nobody told me what the average was. Someone just wants to know which of these places sell pizza for less than average. Right? So it turns out that what I actually need in that question mark spot is yet another query to compute the average. So I have to know what the average is before I can compare things against it. So let's try that part first. Maybe that part will be a little easier. Let's say I wanted to know, what is the average slice of pizza? How much is it priced? That's not so bad. Now all I have to do is select average price from pizza. That's a pretty simple query. So a subquery is basically going to let us take that, sorry, let me go back here. It's going to let us take this average price query that we just wrote, and all we have to do is basically copy that and paste it right where those question marks are. We're going to fill those question marks in with that query that we just computed. And that's your first subquery. Subqueries can get a lot more complicated than this. I don't want to dismiss this at all. This is a non-correlated subquery, if you really want to know, meaning that it can stand alone. It's an easy enough query that we could go write select average price from pizza by itself. It can stand alone, and that's no problem. We can compute that. We could run it. Then we can kind of paste that answer back in here, right? So this is kind of a more simple sort of subquery, but these are the most common types of subqueries that you'll write. So this is where we'll spend our time today, is writing these. One other thing that people ask me sometimes at this point is, why don't you just run the select average price from pizza by itself, copy that number, and fill in the query? Like maybe it's $3. Just go fill in $3, and that original price is less than $3 query. The reason why we don't do that is, it would work. But one, the two-step process of computing the average, then putting it in, can get kind of annoying after a while, like doing 2 steps every time. The other big thing is, what if that average changes, right? Like, what if we add more rows to the pizza table? What if we take some rows out of the pizza table, or so on? By writing this as a subquery and actually putting those 2 queries together, we're able to get real-time information. We know exactly what the average price of pizza is right now, okay, by doing it like this. So definitely recommend writing it like this, not doing the old 2-step back and forth anymore. If you're currently doing that, don't do that anymore. Go ahead and write it as a subquery, because it'll make your life a lot simpler. Okay, great. And here they are. Here's the price. Here's the slices that are less than. I think the average is around $3 or so, maybe a little over, $3.10, something like that. So anything less than that, this is what would be returned in our results. Just those 3 rows that are actually less than the $3.10 or so. All right, so that was a simple subquery. We're going to do some more in the demonstrations, but I also wanted to let you know, so subqueries are anytime that we have a query contained within another query. And they can actually appear lots of different places. Where clauses are probably the #1 place I see these. Yeah, definitely the #1 place I see these are within where clauses, like we just did. But you could actually have them as columns themselves, or you could have them joined with another query, right? You could join them back up. They can appear lots and lots of different places, and sometimes they have special names depending on where they are. But I would definitely say with the where clause is the #1 place that I see them. One other thing to know about subqueries, when we just did this one just now, we got a single numerical value back, $3.05 or whatever, $3.10, whatever it is. We got a single value back. Subqueries do not have to give you single values. They could give you a list of values. They could even give you tabular information. When a subquery returns tabular information, like a full table of values, that is then called a derived table. It's just a special name for a subquery that gives you a table of information. Oftentimes you'll see a derived table in the from clause, but it could also be joined with something else. But you're thinking about these, the subquery part, if it actually gives you a table of values, we would technically call that a derived table, and I'll show you some examples of that as well. Okay, speaking of all those examples, tab 0. Speaking of all those examples, let's dive into a few examples with our learning platform. Okay. So I'll clear everything out. we're actually going to be working with a different table for this section, and it's called lesson_activity. So let's go ahead and just select everything from lesson activity. Sorry, semicolons, habits, a hard one to break. All right. Okay, just to give you some examples of what this might look like, we have, so it's lesson activity. What we're going to have is, an activity ID. This is just a primary key, like an ID number that we could, label all these with. We're going to have the user ID. Which user did this action? Course ID. Which course are they working on? A lesson ID. There's several different lessons within each course. So this is lesson number 101 or lesson number 102, so on. What day did this activity take place? And the final column is minutes watched. How many minutes of content did this person watch for that particular lesson on that particular day? Okay, so our first question we might ask of that lesson activity table is, which lesson views were longer than average? So this should remind you of the pizza question that we just did, except for this time we want to find longer than average views instead of less than average prices. When you're working with subqueries, if this is your first time working on them, I think the way that I like to approach them in the very beginning is to try to write the inner query, that's the thing that's contained within the other select, the inside select, I try to write that one first. If I can get that one right, then I can build my way back out. So I like to write the inner query first and then the outer query if I'm working with these like simple non-correlated subqueries like we are today. So I want to know which of those lesson activities were longer than average minutes. Sounds like I need to know the average minutes watched before I do anything else. So let's do that. Select average minutes watched from the lesson activity table. Just averaging all those minutes. And on average, people watch about 40 minutes of content. This must be a really awesome learning platform. A lot of times people watch like a couple minutes if you have asynchronous videos. But hey, this is a really good one. All right. Okay, great. So we know that this inner subquery is just going to give us a single numerical value, 39. Right? Or whatever it happens to be. This could be real-time data. We could be collecting this as we speak, right? So the nice thing about this is if we're adding more rows, deleting old data, whatever we do, this gives us the most current average minutes watched. Okay. Now all we have to do, we are going to put this in parentheses, right? That's our subquery. We do need to have that in parentheses. We want to now select everything from the lesson activity table where the minutes watched greater than, let's see, was it greater than or equal to? Which ones are longer than average? So just strictly greater than this number. So once you have, this is why I advocate for trying to write the inner query first. Excuse me, once you have, this number, whatever it is, 39 in this case, once you have that number, all you have to do now is compare it to the other minutes watched. And it's just like a regular where clause, like a simple filtering. The bells and whistles were just that we have to actually compute that average when we run this query. So now if we're looking down through things, we should have activities where people have spent more than 39 minutes on the content. And we do. Okay, great. So we have a question here. Will it impact performance if we use a subquery versus a join? So I think you're probably talking about maybe more like the derived table kind of aspect. Um, well, even this one, it's potentially possible to use joins and things here too. Yeah, I mean, it definitely can. It can definitely impact your performance if you use a join versus a subquery. Um, I think typically when you are doing these non-correlated subqueries, as these are called, like these simple ones, subquery is often going to be what you need to use, right? Right, as opposed to a join. I often use these for these simple non-correlated subqueries, as they're called. Um, if you happen to run into a situation, if you move on, you're getting advanced, you do things called correlated subqueries. Now, those can definitely slow things down. If you end up with a correlated subquery, basically the subquery depends on the outer query and you have to end up running it a bunch of times. If you end up in that case, you're going to want to switch to join, probably, almost always, especially if you're dealing with a sizable amount of data. So it kind of depends on the type of subquery. It definitely depends on the type of subquery. Also depends on the size of your data as far as if you want to switch over to a join. Yeah. Good question. Okay. Okay. Great. Okay. I want to show you one more because I think this one comes up a lot too. All right. Let me clear that out. Let's say that somebody asked you, how many average total minutes does of watch time does each course get, right? So let me phrase it one more time. How many average total minutes of watch time per course do we see? So if you think about back to the lesson activity table, okay, we had several different courses, we had different lesson IDs, and we had the minutes watched. Um, Now I'm basically trying to sum up the total minutes watched per course and then find the average of that. Okay. So let me go back over to SQL here. Okay. What you may try to do there, let's say, okay, so we're going to select. We need the sum of the minutes watched from the lesson activity table, and group by course ID, something like that. This should work. We could sum up all of the minutes watched per course. Let's run that. So, oh, sorry, I didn't put course ID. I should probably put course ID as one of the columns I want. But basically, I'm able to sum how many minutes watched total do we have. If I now wanted an average of those amounts, you may try to do something like this. Well, let's just take the average of the sum of the minutes watched. You get a big old error, okay? So when you try to like do these multiple aggregation functions on top of each other, a lot of times you'll get issues with that, right? So we grouped everything up and we aggregated, but then trying to aggregate those aggregates just doesn't work. So this is a place where a derived table could come in handy. So let's go back up and fix our query. Okay. So what we might do instead, I showed you before, this actually did work when we just got the sum of minutes watched. So let's also add in, I'm going to add in the course ID. And let's call this as total minutes, like that. This would work, right? We went back to having the sum of the minutes watched. Let me show you that this one definitely works. I just added the course ID. Okay, course number 1 was 120 minutes and so on. If I now want to take the average of that total minutes column, I can treat this like a table that I am querying from if I use this as a derived table. So let's do that. I'm going to put everything in parentheses because this will be a subquery now that I'm, querying from. And one other thing that you definitely have to do if you are attempting to, work with derived tables, you have to give all of your derived tables a alias. Okay, you just have to do it. It has to know, SQL has to know what to call this thing in order to build all of the things in the back end, right? So you can call it whatever you want, but let's call it DT for derived table. You have to call it something in order for the query to work here. Okay. So if I have that, we can scroll back down to it. This is the table now that I'm querying from. If I have this table, DT, all I need to do now is take the average total minutes. So select average total minutes from. And maybe I'll give this an alias too. There we go. As average total minutes. Give that an alias too. Okay. So I'm basically, I'll run it in just a second here, but I'm creating that derived table where I have summed up the total number of minutes watched for each course. Then I'm averaging the total minutes column. That's something I created here. I'm averaging that total minutes column and saving it under an alias there, or giving an alias there. Now, indeed, it does work, 150 minutes on average. So that's a really common, I would say, common way that you may need to use a derived table is to compute some kind of group aggregates first, then aggregate those aggregates. That's a really common way. The big thing to remember here, the why SQL can do this is because it's computing the derived table first. It's doing the things in the parentheses first, then it can use that as part of its other, the outside query, outer query. One other thing to watch for here, again, we didn't reference DT at all, but we have to have it. If I take that off, I am going to get an error. No, doesn't like that. So you got to give your derived table an alias. You can call it whatever you want. Even if you don't reference it, you still have to give it an alias for the query to run. The SQL has to know what to reference that as. Okay. All right, great. I'm going to jump back over to the slides because I want to show you an alternative. Derived tables are really great, but sometimes people will want to use something called common table expressions instead. So let's talk about those as well. Common table expressions, or CTEs. The good thing about these is you pretty much know how to use them already because they are pretty much just like derived tables with slightly different syntax and slightly better properties, I'd say. A common table expression provides an alternative to the derived table. And the big difference here, you're going to see the keyword with. Okay, so it looks like this. With MyCTE, that's an alias they're going to give it, as, then you'll define your CTE. Then you'll write your select query as usual. So let me break that down one more time. You have with, you have the alias that you're going to give your CTE, or the name you're giving it. You'll have as, you'll have the definition of your CTE, and then you'll have some kind of query that references the CTE. So the reason why I say this is really the same thing as a derived table is because it's just kind of written out of order. If we took that CTE, the definition, and just plugged it in where from MyCTE goes, and just switched the alias to go on the other side as MyCTE, you'd be back to a derived table. It's really kind of about rearranging things, but that rearranging definitely helps in a lot of cases. So as we'll see, I'm just going to do the demonstration in just a second. As you'll see in the demonstration, defining the CTE first makes the code look way cleaner. We'll go from like being a little confused about where the subquery is to very easily being able to see where that CTE is. There are also a host of other benefits that I'll talk about in just a little bit. But yeah, I mean, I think the organization alone is a big factor of why people often switch to CTEs as opposed to derived tables. So let me go back to the coding. So I basically want to start off by just reworking this one into a CTE, right? So what we just did was we found the average total minutes where by course ID, right? So we totaled up the number of minutes watched for each course, and then we averaged those. And we talked about how we had to do the summing or the totaling first before we could do the averaging. So I'm going to convert this into a CTE as opposed to a derived table. And with a GUI system like this, it's going to be easy because we can copy paste. I'm just going to copy the entire derived table, cut that out, and paste it up top. And yeah, I'll come back to the main query in just a minute. I'm going to write with, now let's call it MyCTE as. Here we've got the definition of what the CTE should be. Then we're going to have our select, our main select. So I'm selecting the average total minutes as average total minutes from, now we don't have DT anymore, we have my CTE. And that's it. And that's it. I'm going to hit go. We should find that same 150 minutes that we saw before. All right, so basically all I did was define the table up front. That's basically the big win for CTEs. One of the big things. There's other things too, but that's like the main difference is that we say with my CTE as, and then we define it. Then we can write our query however we'd like. The big benefit here is that you can tell, okay, we're pulling information from my CTE because it says so right there. I don't have to define the derived table within the main query. And I think it does make a really big difference in terms of readability. If you're looking at my code for the first time, wow, you made a CTE, then you used it. I see exactly what you're doing. The other way with the derived table where it was like actually in the middle of all the code, kind of looks like a whole jumble of mess, right? So I definitely think people prefer this these days to write it more like this instead of the derived table, unless you've got something really simple going on. I usually think people will typically prefer the CTEs. Okay. All right, let me tell you a little bit about some differences between derived tables and CTEs, and then I'll ask for some questions as well. So what's the big difference between derived table and CTE that we just saw? Well, one other really nice thing that you can do with CTE, if we've done with my CTE as, and you've defined it, you can then reference that as many times as you'd like within your query. Okay, so here's an example of that. I first just defined O as, as all of the orders where the price was less than $10, right? So my low priced items there, orders. Then I can reference O as many times as I need to throughout my query, and it makes everything look really nice, right? So I've got a reference, there's O again, I've defined it. I've got a reference to O like 3 different times throughout my query, but everything looks really nice and streamlined because I've defined it up front and then I've just referenced it from there on. The other thing I can do is, well, again, I think it's just easier to read queries with CTEs. That is personal preference, but I would say it's a preference that I've heard from just about every person that does SQL. So it's a big preference. A lot of people prefer just the way CTEs look. Especially when you have multiple CTEs. So we didn't do it in this course, but as a more advanced step, you could have as many of the, well, maybe not as many, but many of those CTEs defined. And you would basically just write out the definition, comma, write out another definition, and go on from there. Then you could join CTEs together in your main query or so on. It's so much easier to read this than actually having those definitions of those, subquery derived tables within all the code. It'd be a lot easier to read this. You can even, I don't think I have it here, but CTE2, the second one, that definition could even reference my CTE1. So queries that kind of like build on each other are great for having CTEs as opposed to derived tables. It's a lot easier to read all of this. The only drawback at all is that sometimes, legacy software doesn't always support CTEs. And by like, we were talking like at least 10, 15 years ago, maybe 10 years ago, at least 10 years ago, right? So any software within the last decade or so, I would say, pretty close, should support CTEs. But every once in a while, you'll come across some systems that don't support them. So if you think you might have code that needs to work with, needs to port to really old systems or, needs to work with older software, then you may not even be able to use CTEs. But I would say that shift happened quite a while ago that pretty much all the platforms now will allow you to use them. Okay. So any questions about subqueries, derived tables, CTEs? We did a lot there. If there's any questions, let me know. Okay. We did have one question here in the chat. It's a really good one. Do derived tables stay per session or are they temporary tables? No, they are not. And so maybe it's another drawback of derived tables and CTs, same. They're only going to exist within the query that you derive them. They don't stay around. They're not per session. They're not, they're not views. They're not temporary tables or none of that. Nothing's actually getting stored on the back end, pretty much. So they're not like temporary tables at all. They don't stick around. You can't keep using them in other queries. They only exist within the query that you define them. So if you have like a table that you need to be referencing a lot throughout your day, temporary table instead, or maybe even view if you don't, if you don't need it to like precompile or whatever, it depends on how you need to use it. But yeah, you'd want to use something a little more permanent. Yeah, these only exist in the query that you define them. Okay, great. All right, so we have a poll question for you to move into the next bit. We've been talking about subqueries and CTEs and derived tables. Let's talk a little bit about joins. So what do you find the most challenging about SQL joins? Choosing the right join type, selecting the columns from each table, recognizing when to use a join, or writing the on clause correctly. Okay, let's go ahead and take a look. Choosing the right join type. All right, cool, yeah. Yeah, choosing the right join type can be really tricky. So let's definitely review that a little bit before we move on. But yeah, all the other things can be tricky too, for sure. Definitely. All right. So, to review a little bit of the joins, we're not actually going to spend a ton of time talking about the differences here between these, but just to refresh you a little bit. This is, people go back to the Venn diagrams often. I do like to think about the Venn diagrams. So if each of these two circles are the two different tables that you are joining together, an inner join is only going to preserve rows that match from each table that actually have values in each table and they match, right? So if you have a bunch of missing values, like in your column that you're actually joining on, if you have a bunch of missing values, inner join is not going to be preserving those. Okay, it's only taking matches that places where we do have matches between both tables, right? Missing values get tossed. Full outer join, on the other hand, keeps all of those possible missings, right? So if we have a bunch of rows from table A that are missing the values within the column that we're trying to compare, full outer join is going to keep those. Same thing with the other table. Both tables get to keep all their missings, and those just appear as rows with null values for everything that we had coming in from the other table. That all just gets filled with null if we don't have a value in the place that we're matching together, the on clause. Left join, on the other hand, treats these two differently. The table that we mentioned first, the left table, gets to keep all its missing values. The right table, the one that we're joining onto that, does not get to keep its missing values. So I actually was trying to think the other day, which one of these do I use the most? I honestly use left join a lot because of the type of analyses I do. I'm often bringing in supplemental information and I just want to add that where available. If you're in that kind of situation where you've got a main data source and you're just trying to supplement that with other data, probably left join because you want to keep all of the original rows and you're just trying to add to it if possible. You don't want to keep all the extra stuff you're adding and only where it matches. So I end up with left a lot in my line of work, but I would say also people use inner quite often too. Full outer is a little bit less common, and I didn't even mention right because if you have a right join, you could really just switch those two tables in your query and make it a left join. So that's what I do. All right. That's your brief join walkthrough, because what we're going to talk about in today are two different kind of a little less known, a little less common types of joins. First up, we have the cross join. The cross join, I feel like, is probably one of the most simple ways to think about joining information. The cross join basically takes all the information from one table and matches it to all the information in another table. It makes every possible combination between those two tables. So in this case, I had an example of objects, the sweater and the yo-yo, and I have an example of people, Mary, Lucy, and Bob. And I'm going to get one row for every single combination. Mary gets paired with both the sweater and the yo-yo, then Lucy gets paired with the sweater and the yo-yo, then Bob gets paired with the sweater and the yo-yo. You get it. And everybody kind of gets a turn with each object there, right? So as you can tell, as your tables get bigger, as we have more than 3 people, which we probably will, the product of a cross join can get really, really large, because however many rows you have in the first table, multiply that by however many rows you have in the second table. That's how many rows you're going to get in a cross join, right? So 2 times 3 is 6, not so bad, but 1 million times 1 million. I mean, it's just going to be insane. So we don't use them that often in real world, except for some specific cases. So we'll talk about that in just a minute. But here's how you execute a cross join. Basically, let's say you're selecting out all the columns, which we did here, from objects O, cross join people P. Okay, so I'm giving objects the alias O and people the alias P. And I'm just writing cross join in between them. Right? So just like a regular join, it's just that now we specifically reference a cross join. The only thing that's really, really different here is that we do not have an on clause because we aren't matching on anything. We're getting a combination between every row and every other row. So we don't end up having an on clause. Cross join would throw an error if you tried to use an on clause there. The other one we'll look at today is called a self join. So self joins work just like regular joins. It's just that you're going to be having only one table and joining it with itself. So let's say I had a list of 3 people and they all want to be pen pals with each other. So I have the country that the person lives in and their name. So what I could do if I wanted to match up and wanted to make a bunch of pen pal options, I could execute a cross join, couldn't I? I could say, okay, pen pals, cross join, pen pals. The way that we'll do this is that you're going to be using the pen pals table twice in the join there, but you'll give it 2 different aliases. So I'm calling it pen pals. The first copy of that is called A. The second copy of pen pals is called B. So if I need to reference the columns from those or any other things along the way, I can refer to them as like a.name. That means the first copy of pen pals, the name column from the first copy of pen pals. B.name is the second copy of the pen pals table. By the way, we don't actually create another copy. You can just use that as a mental model. It's just that SQL is referencing that table twice when it's doing its join. All right. The result looks like this. Oh, right. There we go. The result looks like this. And so take a look at that. Is there any issues with what we've created here? Definitely. There are definitely some issues with what we created. So the first problem is in the first row. We have, by doing the cross join, we have actually paired up Joyce with herself. So, I mean, maybe she wants to write a journal, but usually you don't want to be pen pals with yourself, right? Well, maybe you do, but probably not. So what we're going to do to address that is take this query that we just did and add some filters, right? So we might do where person 1 is not equal to person 2. Do that. That would rule out the Joyce row, the Beatrice, and the Mevis row. But there's actually, so let's go ahead and get rid of those. There's actually another problem here. The first row is Beatrice, but take a look down at the third row. That row is Joyce. So if we want only unique pairings of people, order doesn't actually matter here in this case. Depends on your problem, but in this problem, Joyce paired with Beatrice is the same thing as Beatrice paired with Joyce. So the way that we can get rid of that is we can actually switch that not equal to a less than. This is saying that person 1 has to be less than person 2. And in this case, we have text, so less than in terms of text means alphabetically less than. So the very first row is Joyce less than Beatrice. Does Joyce come before Beatrice in the alphabet? No. So we get rid of that one. Does Joyce come before Mevis? Yes, that one's good. And so on. So we're checking each of these rows alphabetically to see is the first person alphabetically before the second person. We could have, of course, done greater than if we wanted to, but I did less than here. And the result, we actually only have 3 people, which is three pairings, excuse me. 3 pairings, which is perfect. Each person paired with every other person. So this is common if we are doing a self-join, especially if you're doing like a cross-join, self-join kind of thing, is that you may end up needing to add some kind of filter to make sure that you don't have same pairing happening like over and over again. The less than actually would also get rid of the Joyce combinations or Beatrice combinations, because the same word is not less than the other word, right? So this would work for both cases. Yeah. Okay. All right, so let's do a little bit of a coding demonstration on these joints. Okay, so the very first one is, let's say that we are building recommendations for course pairings. So what are all the possible course pairings that we might suggest? And order does matter in this case. Okay, so for this one, we're actually going to need the courses table. And since we haven't worked with that one yet, let's take a look at it. I'm going to collapse this and we'll take a look at the courses table. I'm just going to click on it. Okay. I may have to reset everything. We'll see. Okay. Looks like I need to reset. Yep, the sandbox expires and then we have to start it up again. Nice thing is this is probably happening for you too, so you can see exactly what you do when this happens. All right, I'm going to import that data set again. And I'll make sure to use that data set. Great. Back on target now. Okay, so the courses table, let's take a look at that. All right, so here's the different courses we have available. We have SQL Basics, Intermediate SQL, Python Basics, Data Visualization, Machine Learning, and R for Data Analysis. So the learning platform is considering kind of building pathways like, oh, you just finished SQL Basics, why don't you try Intermediate SQL, something like that. So they'd like to see every possible combination of these courses. What could they possibly pair one after another? So let's build a join in order to show them that. Okay. So if I want every possible pairing, when somebody asks you for that, that should be kind of your like, oh, I should probably do a join, right? A cross join, excuse me, a cross join to get every possible pairings. That's always the trigger for me to say, oh, okay, I probably want to do cross joins. So we're going to select, and I like to build the join first. We're going to select from the courses table. Let's give it an alias. Let's call it C1. Cross join courses C2. So not only is this a cross join, it's also a self join because we're matching all the courses with all the other courses together. And now what's left is thinking about what columns do we want. We probably just want the names of the courses. I think that's probably all we want. So that's called course name as first course, C2.course name as second course. And I forgot a comma. There we go. Okay. Okay, so all possible combinations is what alerted me to using a cross join. And because we want to pair all the courses with all the courses, that's what alerted me to a self join. All the information is found within one table, so we need a self join. The main difference here is that I'm referencing the same table as both the left and right. So I do need to give it two different aliases here, just to keep everything straight, which copy, well, again, it's not actually making a copy, but mentally you can think about which copy are we referencing, right? And I also, in the question, it said order does matter. So I labeled these as, here's the first course you would take, here's the second course you would take. And so I'm referencing the course name from the first copy of courses, then the course name from the second copy. All right, let's try to run that. So here's all the different things that I could do. I could have R for data analysis first, then SQL basics, machine learning first, then SQL basics. So I'm kind of just seeing all the different options. And if we look down here far enough, we do also have SQL basics first, and then Python basics, or Python basics first and then SQL basics. We have both options, and maybe there's going to be some other criteria we use to evaluate what options make sense for our learning platform. Now, you may be looking here, what kind of is there any problems with what we've done here? You always should be double checking your work. And I do see one. There is a row for, for every single course paired with itself. So SQL Basics paired with SQL Basics. Probably don't want to recommend to someone who just finished SQL Basics, hey, try it again, do another round of SQL Basics. I don't think they'll be super happy with me if I do that. So we do need to add something to our query in order to get rid of those exact, one course funneling into the other, or to itself kind of problem. As you might imagine, we did do this a little bit in the slides. All I need to do is add a where clause here, where I'm just going to say C1 course ID. I could use the name, but maybe there's a couple things that are named the same. The course ID should be unique here. The course ID should not be equal to the second course ID. And if I run that, now I should not see a row for SQL Basics paired with SQL Basics, and the same for the rest of the courses. Okay. I did want to mention a couple of things at this point. First one is, remember how I talked about cross-join does not have an on clause? It doesn't. You can't put an on with a cross-join. You can put a where with a cross-join. And so sometimes I try to think about SQL, like, what's the difference between an on clause and a where clause? Don't they really do the same thing? Yeah, I mean, they can do very similar things, right? Or pretty much the same thing as far as if we're just talking about achieving results. It turns out that if you are creating a cross-join with a where clause like this one, you can actually rewrite this as an inner join with an on clause. Yeah, I mean, well, again, we got to think about what we want to do with our null values. So that's a little bit tricky, but you could potentially rewrite this one as some other type of join with an on clause instead of a cross join with a where clause. So sometimes people say, I try to avoid cross joins altogether. So I'm just going to use, other like left, inner or outer instead, because cross joins could potentially explode. If you don't have any kind of filtering on this, you could get lots and lots of rows. So yes, a lot of people are more comfortable with using an inner join with an on clause as opposed to a cross join with a where clause. They'll typically give you the same sort of results. It's just on the back end, your RDBMS may be rewriting your cross join as an inner join. So yeah, you got to think about all those kind of interesting things that could be going on as well. It might be optimized into an inner join instead. Yeah. All right. Okay, any questions about joins before we do unions and wrap up this section? All right, the final part of this section is about unions. And so I just want to touch this briefly. I do think unions are really important when they are necessary. They can be really important. So what does union do? Basically, here's an example. Let's say we have some college students with scores. We also have some university students with scores, with grades here. With a union, I could basically take these two tables and paste them together. So I'm pasting them together. Not in the same way as a join, but one on top of another. Okay, so my result here, I could have students from both the college and the university, as well as their resulting score or grade, all pasted together. And what I've effectively done here is the union operator is combining information by stacking the query results vertically. So here's a diagram to help you with that. Basically, you're taking one table and adding another table on top of each other, like that. So joins are basically stacking information horizontally or adding information horizontally. Union is adding information vertically. It's a little different way to do things. One thing to kind of tell you, here's what the union is going to look like. We'll take a look at the syntax here. What I'm doing in the query, I'll basically take the first query to get information from the first table. So here I'm getting the name and the score from the college table, getting all the students from that table. So that's all of these students. Then I'm going to do a union. I'm actually going to, oh, sorry, that's the first query. Then I'm going to do a union all. We'll talk a little bit in just a second. What's the difference between union and union all? But in this case, let's say we do union all. Then we've got all the students from the second query. Sorry for the spacing issues there. I'm getting name and grade also labeled as result from the university table. And in the final table, I've just pasted everything together. So union all is going to do exactly what I just said. It's going to take everything from your first query, paste it with everything from the second query. If I had union instead of union all, there would be one extra step. Union would go through the table and look for duplicates. It basically sort everything so that we are looking to see if there's any exactly duplicate rows. Many rows look exactly the same before giving us the results. So if you don't care about duplicates, you'll definitely want to use union all. It's a lot faster than union. If you do care about duplicates, if you want to dedupe your list, then you would use union instead. There are definitely some other rules about unions. So you can see here I relabeled both of those columns as result. I didn't relabel the name. I guess I wrote student there. Anyway, that should be name, but basically union will go with the name that the first query is calling it if you don't re-alias anything. So that doesn't really matter if the names are different. What does matter is that you're going to need to have similar data types or data types that can be compatible with one another and the same number of columns in both of those so it knows how to stack everything together. Okay. Well, let's see a quick example of that. There we go. All right. So let's see a quick example of that. One thing we may want to do for our learning platform is get a master list of emails for all the people that have ever interacted with our product. So we know we have the users table. It's here. The users table has a bunch of emails for all of our users. Maybe we're going to send out a big company announcement about something. Then we also have another table called leads, which we haven't seen yet. Here's the leads table. So this is another set of another email list, but these are people that didn't necessarily sign up for our product, but they did do something like sign up for our newsletter or download a cheat sheet or something like that. So we have a bunch of different emails, and they are contained within two different tables. If we want to send a big company announcement, we may want to union those together and then send out the email. So let's try that. So union is pretty simple. Basically, I can select email from users and then select email from leads. All I need to do is in the middle, I either put union or union all. Let's start with union all, and we may revisit that. All right, so we've effectively taken all the emails from the users table and pasted them with all the emails from the leads table. One thing is a little bit tricky. If we think about this long enough, we may have people that are both our customers and did some kind of lead generation activity. So it would be nice to know, to make sure that we're not sending this email to somebody twice. Let's go ahead and order these emails by, from alphabetically, just to see if we have anybody like that. So order by email. We'll just sort everything alphabetically. Okay, problem there. There we go. Just need to hit go again. There we go. All right, and so you can see what happens. We have Alex at example.com, and we also have Alex at example.com. We have Chris at test.com and another Chris at test.com. So we definitely have people that are both our users and have done some kind of lead generation activity. So if we want to deduplicate this email list, what we could do is do union instead of union all. So this actually would go through and say, oh, Chris at test.com was there twice. We're going to get rid of one of those. But there is an issue. Take a look at this Alex at example.com. The user's emails, as we know, are notoriously unclean, right? We would need to use some string manipulation to clean those emails up before we can dedupe this list. So maybe we'd replace the tildes, get rid of them, we'd trim it, maybe even do some lowercasing, though it wouldn't really matter too much. But we would maybe want to work with those emails a little bit more before we paste them all together. But I'll leave that to you to do as an exercise. But that's the problem now that we're having, is that we would need to do some string manipulation first before union could effectively get rid of those duplicates. Okay, my last tip there is, again, you'd want to stick with union all unless you care about duplicates. Union all is going to be a lot faster because union is actually going to be sorting things and deduping them and all those kind of things. So union definitely is slower, but if you do actually need to dedupe everything, then you can use union. Any questions there? I'm going to leave an exercise for you in the chat, but we're also going to take a break. So you can choose. If you want to work on it, that's fine. If you don't, if you just want to take a break, that's also fine. So let me go ahead and put a couple of exercises. We'll just put one exercise in the chat. If you'd like to do it on the break, you're welcome to. If not, that's okay. And we'll go ahead and do a 7-minute break. So go for it. Go take a rest while we, or do the exercise if you'd like. I'll see you back in 7 minutes. All right, welcome back, everyone. So if you were able to during the break and you wanted to work on the question I put in the chat, I think that there are multiple different ways to address that one. The question was, who are our top customers? And get the email addresses and total payments of users who made payments of $80 or more. There are definitely multiple ways to do this. I like to use CTEs. They do, I think, simplify things a lot. So I'll put my answer in the chat as well. You may have had a different answer, and that's totally fine. But I basically structured this as a CTE, and then I joined the CTE onto the users table. There's the answer that I had. You could have had something else, and that'd be totally fine. All right. So for this last hour that we have together, I think it'll be best to focus on window functions. And then I've been told that you do have the slides already. You can have a look at the analysis patterns on your own. But let's go ahead and spend our last bit of time together on window functions because they do show up in all kinds of things. And I've told people before, I definitely believe this, that window functions are really when you elevate yourself to the next level of SQL is when you learn window functions. You're like, okay, now I'm really, really into SQL. So yeah, I think they're a big differentiator between people who are kind of scratching the surface and people who are like really using it to the best of its ability. Okay, so my first question to you is a poll. What do window functions do? Does anybody know? Your options are, would they give group summaries per row or provide running totals? Do they rank items overall or by group? Or maybe I have no idea, and that's okay. You can tell me what you think window functions do. Okay. You may still be deciding, and that's okay. It turns out, let's see what you all said. I have no idea. That's totally fine. We're going to talk about it today. That is totally fine. It turns out it was a bit of a trick question. I'm getting to be a bully in my old age here. So, in our final hour of this, they were all correct. All three of those things, and even the I don't know, that's fine too. That's correct as well. Window functions, it turns out, can do all of these things for you. They can give you group summaries per row. That's probably the number one way that I use them. But they could also provide running totals if you want to do a cumulative tally of some item, some dollar amount or something. They could also rank items overall or by group. So we're going to take a look at these couple different things that window functions can do because I think, yeah, they're just really, really cool. Okay, so here's my first one for you, and it's all about determining popularity. So let's say that we have some students that are running for class, whatever they are. They're running for some kind of class election. So we have the name of each person, and we also have how many votes that they received. So we could definitely sort these, right? If we wanted to know who got the most votes, we could just sort by votes in descending order, and we would have that, I believe it's Stacy has the most votes out of everybody. But what if I also wanted to get like a numerical, like a number next to each person saying who was the most popular or who got the most votes and like actually give them a number from most to least, right? We could do that with a window function. There are other ways to do it too. That's SQL for you. But you could definitely do this with a window function. So, right, as I just said, you could just sort these descending and find out who had the most votes. But we can also do things a little bit differently to get an actual ranking for each person. So we could select everything from the election results table. We could also select something called rank. And so rank is basically a function that will provide rankings for us. And one thing you should also notice about ranking is that it keeps any ties that we have. If anybody has the exact same number of votes as each other, they'll both get the same number in our rank. Then if we're doing a window function, we'll want to say over. That's the big red, well, not red flag, the big flag for SQL to know that we're doing a window function is the word over. So we're ranking over, and I've given it an alias, popularity. Over is the main keyword that we need here, and it alerts SQL that we are doing a window function. Then we're going to order all of these by votes descending. So before, we already saw this clause before when we were thinking about who has the most votes. We would be sorting all of this information by the votes column in descending order. Then we're ranking those rows by seeing who has the most votes and so on. So this is a window function. In this case, we're ranking over order by votes descending. So that order by votes descending is what tells us how to sort these data before we do the ranking. And, oh, I just said that, but it tells us how we're going to sort the data before performing the window calculation. All right, here's our results. We have Stacy with the number 1. She's got the most votes out of everybody. And we go all the way down. What I wanted to alert you to is John and Elaine. Right down here. So John and Elaine have the same number of votes. And because we used rank, that function rank was able to say, okay, they both have the same number of votes. I'll both give them both the number 5 for their rank. And then we're going to skip the number 6 entirely and go to number 7 for Rob, the last person. So rank preserves that tie, whereas other functions like row number, for example, does not preserve the tie. Okay, so that's cool. We probably could have done something pretty similar without the window function though, right? Okay. What if we also have roles for each person? So what if, like normal elections for student body, let's say, oftentimes we'll have people that are running for different things, maybe president or secretary or treasurer. So what if we also know what role each person wants? Can we come up with rankings now for who won each role of this election? Okay. So we'll go back to our window function that we just talked about. We're selecting everything from the election results column. We're also going to rank each person by the number of votes descending. But in this case, we need one more line of code because we have the role that we'd like to specify. We want to come up with a ranking based on role as well as the number of votes. Okay, so I'm adding just one more little bit of space here in the code. We are going to now do partition by role. Okay, so partition by basically gives us how we want to split the data into windows. So this is where window function gets its name, is that you're able to split your data into these little windows before doing the ordering and the ranking and all that stuff that comes next. You're actually taking all the data, splitting it up into roles. You can think about those as individual partitions, then order them by votes and come up with a ranking for me. Again, mental model. This is how I can think about it. It doesn't exactly have to be working that way, but this is how I can think about what the window function is doing. All right, so let's break down general window functions. What is the syntax that we're going to be seeing there? Window functions are always going to be doing calculations across rows, and they're always going to be giving us one value per row. So we'll also see later on that we'll be able to do like group statistics, but we're still going to be getting one value per row, even if we've thought about groups in some way. Okay, this is the general sort of syntax that we'll see. We'll have some kind of function or calculation. It may be rank, or it may be average, or it may be sum, or any of those kind of like functions, aggregate sort of functions, or ranking functions. Lag would be another one. Some kind of calculation. We will see the keyword over. Then we may see some kind of partition by, which tells us how we're splitting those windows up. Now, as we saw before, this is optional. You don't have to split your windows up at all, but oftentimes you will see some kind of partitioning. You also may or may not see some kind of window sorting. There are a couple RDBMSs out there that require you to have some kind of order by in your window function. You can always get around that by saying order by the number 1, and that just skips the sorting, right? So both partition by and when the order by, I would consider both of those optional. In a lot of RDBMSs, they are optional, both of them. But one is doing the splitting for your windows, and one is doing the sorting of those windows. All right, so let's go try a couple of window functions and see what we can do here. Okay. All right, so let's say that we want to, within each course, rank the lesson views from most to least in terms of minutes watched. Okay, so that's back with the lesson activity table. Let me show you that one again. It's been a little while. So what we want to do is for each course, so let's say this is course number 1. I think that's SQL Basics if I remember correctly, but whatever course that happens to be. There are various different lessons within this, and there are also different minutes watched for each person, right? So we want to rank all these different lesson views from the most to the least in terms of minutes watched. So for course number 1, what was the top most watched, not top most watched lesson, we're not aggregating here, but just like time that people happen to view something from this course. All right, let's go back over here. Okay, so we're definitely going to select, since this is an analytics course here, selecting everything. We are going to get everything from the lesson activity table, so let's go ahead and get that. All right, and now it's just a matter of like what columns and things we want. So we need to know something about courses, so let's go ahead and get that, course ID. We also maybe want the lesson ID, perhaps. And we also want the minutes watched, because we're talking about which lesson viewing session was the most minutes watched and so on. So we would like to know what those minutes watched are. Now it comes time for our window function. So let me read the question one more time so we can think about what pieces we need here. Within each course, rank the lesson views from most to least in terms of minutes watched. So the first word that, well, within each course kind of tells us something too. But the rank the lesson views, it says it kind of right in the question. I need the rank function in order to do this here. So I'm going to rank. That's my first thing, is like, what kind of calculation am I trying to do? In this case, I want ranks, numerical ranks. So I'm going to start with that. I want rank. I need a window function because, well, 1, this is the window function section. You know it needs a window function. But 2, you're kind of thinking about, if you're using rank, you're going to be doing window functions, right? Okay, so if I'm doing a window function, I need over. And I'm going to go ahead and put some parentheses in here just for making things look nice. We do need those parentheses after over anyway. Put an extra space in here. And let's go ahead and give it an alias. Again, I like to just go ahead and do these things that I know I have to. So we'll say as watch rank, maybe something like that. Okay. So we had rank, we had over. Now it comes down to, do we need partition by and do we need order by? So both of those are optional, depends on kind of what you're trying to do. So partition by helps us split things up into windows. So if I'm reading the very beginning of that question, within each course, rank the lesson views. So the within each course is what is alerting me to the fact that I do need partition by because I'm partitioning by course before doing the rankings. Okay, so I definitely need partition by. I'm going to do course ID. Again, you could probably do course name, but just to make sure that they're all, I don't know if course name is even in there, but it may not even be in there. I think it's just course ID. Yep, just course ID. So that's what we have. We're going to partition by the course ID. Then do we need the order by? Within each course, rank the lesson views from most to least in terms of minutes watched. Yes, we definitely need the order by as well. We need to be able to sort each of those partitioned windows by the minutes watched, because that's how we're determining our ranking. Okay, so order by minutes watched. And then don't forget, we have to also decide, should this be ordering things ascending or descending? So in this case, it's asking us to rank from most to least. So we actually want to be ordering descending. In this case, we want the most minutes watched first and then down to the least minutes watched. So hopefully I gave you a sense of how I'm thinking about things when I come across a question like this. I'm literally breaking down every single word. I'm, going over it in my head a few times. And I'm trying to pick out a couple of things when I'm writing these window functions. First, what function do I actually need here? What calculation do I need? Am I trying to find an average? Am I doing rankings or what? I know I'm going to need over. Anytime I have a window function, I've got to have over. Then I'm trying to think, do I need to partition these up into windows or not? Do I need to sort those windows or not? Those are the questions I'm asking myself to build the window function. And each of those components, you can kind of go back to the question and just keep rereading it until you can answer all of those questions. All right, let's see if it works. Great. Okay, so if everything's worked as it has here, we have our very first course ID, number 1. We'll see all the number 1 rows first. So that's another thing when you're doing these window functions. You're going to be splitting off by those partitions, as I talked about before. You split off by the partitions. You will see those in numerical or alphabetical order, unless you order them some other way. But if you don't do an order by or anything like that, you'll see all the number 1s, then all the number 2s. You'll see all your partitions will be the first sorting in the results. And then you'll see everything ordered by the minutes watched, which is the other thing we wanted to know about. So you'll see, again, it's not total minutes per lesson. It's of these individual sessions that people are doing. There was someone who watched 30 minutes of lesson number 101, so that gets a rank of 1. There were 2 people who, or 2 different times, could have been the same person watching it again, 2 different times that people watched lesson number 102 for 25 minutes. So that is going to get, both of those will get watch rank of number 2 because rank preserves those ties, and so on. One thing to notice, your null values are getting the lowest rank. So you're keeping the nulls, they're getting pushed to the bottom, the lowest rank. Depends on what you want to do. You can always filter those out if you don't want them. And then the other thing to notice is that we start back over when we get to the second partition, course ID number 2, we start back over with rank number 1, and then we go down from there. Okay, So every time we switch to a new partition, we will start back over with rank 1 and then order them. Okay. Someone asked, can we see the question that we are coding? I will absolutely put that in the chat. That was the question. Within each course, rank the lesson views from most to least in terms of minutes watched. Yeah, I can do that. Like I said, you do have these null values for the minutes watched. If you wanted to get rid of those, if you don't, I don't know if it makes sense to have a ranking of 6 for an unknown quantity. So what I could potentially do is go back to my query. And remember, this is still, regular SQL. You can still add other clauses here, even though you have window functions. You can't do like a where for the window function. You would have to do that separately with a CTE, but you can filter the individual columns themselves. So where minutes watched is not null. Now we've actually gotten rid of all of those, and we won't see them in the ranking. I said that a little bit quickly, but I did want to point that out. Let's say we were trying to, let's say I tried to do something like this. And watch rank is less than 3. Let's say I wanted to get the top 3 or top two, yeah, let's do something like that. Let's say I wanted to get the top 2 sessions for each of these. This is going to fail miserably. So I'll show you that. Error. The reason why this is failing, so I'm trying to use where with watch rank. Watch rank was my window function that I created here. So the window functions are actually happening after you do the where filtering. So the where filtering should really just pertain to the individual underlying columns of data, and you cannot be filtering on the results of your window function, right? So the way to get around this is to use a CTE. So I'll do that real quick too. So these are so useful, as I mentioned before. Add that with something like that. Okay. So if I did actually want to filter on the watch rank itself, like get the top 2 for each of those partitions, I could put all of my whole query that I just, with the window function, all that, in a CTE called MW. Then I could select everything from MW. Oh, I can't say and. This should be where watch rank is less than or equal to 2. Now I am able to filter on something that I've aliased the window function itself. I can filter on that if I want, because the entire CTE is calculated first before I go do any of the other main query stuff. Let's try that one. Now we're good. Okay. So I do think that's really helpful. If you need to filter on the results of a window function, you can absolutely use the CTE. Yeah, not having either. Yeah, having no. I think I guess I'm gonna have to do some experimentation. Question in the chat was like, what about having instead of where? I think the window function is going to happen after. I would have to look and see, but I think that's going to happen after anyway. So yeah, I don't think you can put it in the having either, but you can definitely do experimentations and see. All right. Okay. We also had a question about how are we deciding the partitions here? I assume we mean on this example that we're working on here. How are we deciding the partitions? Whenever I come up with my partition by, I'm usually, yeah, again, rereading the question, it's within each course, rank the lesson views. So when I'm thinking about how I need to rank things, I'm basically wanting a rank per course ID, like each course. So the partition by is always like how do you want to apply your calculation? So in this case, I want to rank within each course. I want each course to be its own little mini bubble thing that I am ranking, and then I'll go to the other course, and then I'll go to the other course, and so on. So the partition by is like, how do you want to split everything up? And the beginning of that question, the within each course, is what alerts me to partition by the course ID. I think in my experience, the partition by I can usually figure out, but the order by sometimes trips me up. But maybe you're different, it could be different. Sometimes the order by is a little less obvious, I guess. Yeah. All right, let me show you a couple more things that window functions can do before we wrap everything up. Window functions can also create group summaries, and this is one I use a lot as a data analyst, data scientist. If I wanted to, let's say that I want to find out the average number of votes per role, something like that. So if I wanted to find out the average number of votes per role, I could just do a group by, right? But what if I wanted the average number of votes per role as a column next to the votes that the person got? And this can be really helpful or the total number. I think I'm going to do total number here, actually. Could be average, could be total, but I think I'm going to do total number here. Because what if you wanted to know what percentage of the total pool of votes did this person get? You would need to have the amount of total votes per role as another column in order to compare those things. So you can do that with a window function. So let's say I'm going to select everything from results. Oh, to do average. Okay, I went with average here. I want to know the average votes per role, let's say. So I could do average votes over, and now do I need partition or do I need order by or both or what? If I want to know the average votes per role, well, I definitely need partition by, right? Because it's the average votes per role. The per role part is telling me I'm going to partition by the role. And it turns out I don't need the order by at all here. Put the partition by. I don't need the order by at all because I'm doing some kind of aggregate statistics here. I'm not ranking anything. They don't need to be in a certain order before I present the results. So this one doesn't actually need an order by, but it does need a partition by. If I did this query, I would be able to then have a new column that says average votes, meaning, how many votes on average did the treasurer position get? It turns out that a lot of people voted in some of these and not so many people voted in the other ones, right? So you can kind of see like, oh, a lot of people are voting in this treasurer role, and there's only 2 people splitting the vote. So you can kind of see those sort of things. So on average, John is getting 30 less votes than the average treasurer candidate. You can see things like that. You could definitely, again, SQLs can do so many things in so many different ways. Another way to possibly get this instead of a window function, you could group by to get those average votes and then join it onto this table. You could absolutely do that. It depends on kind of what makes sense to you. Both are going to give you the same results. I kind of like the window functions just because I don't know. I think they, again, make sense to me. I like how they work. But yeah, you could also do a group by and then join that onto the main table. But the big difference here from a group by is that window functions are going to give us one value per row. Even if we are kind of grouping by that role category, we still are getting the average votes for every single row, just matched up to whichever role the person is, right? Instead of getting just one value per group, we're getting them per row of our original table. All right, let's try one more coding demonstration here about these window functions. Okay. Let's see. Okay, here we go. Okay, so for this question, I'll put it in the chat as well. Oh, you can't see my screen still. Let me try that again. There we go. Okay, great. Okay, so for this question, again, I'll put this one in the chat. Let's say that we want to find the total fraction, the total minutes each lesson activity contributes to the total time watched for its course. Okay, let me put that in the chat and we'll dissect the question a little more. Yeah, do window functions versus alternative ways of doing it have different impact on performance? And I'd say probably. Window functions, to the best of my knowledge, I don't know that they're like notoriously slow or anything like that. What you can always do is check, so in MySQL it's called explain. There's other words for other syntax for it and other RDBMS. But you can have a query with a window function, wrap it with explain for MySQL, and just see kind of what are the steps, like how many different things are we going to have to do, what order are we going to do things in. You can have it explain to you what the query is going to do, and you could test that against one with a group by, with the join, and so on. Yeah, as far as I know, I don't believe that window functions are notoriously slow, but yeah, you can always check something like that with explain or whatever the word is for your RDBMS. Okay. All right, so now we're trying to find the fraction of total minutes that each lesson activity contributes to the total amount of time watched for its course. What a question. Okay, let's start with something relatively simple, and then we'll see here. Okay, so first off, maybe I want to just find the total number of minutes for each course. Let's say I wanted to do that first. Again, I can do it with, I could do this with a group by, but if I wanted that total number of minutes per course, just as a column on my lesson activity table, then I could use a window function instead. So let's just build this up. We're going to select everything from the lesson activity table. So to remind you, here's what it looks like. We have each user, course, lesson combination here, when they did the activity and how many minutes they watched of that lesson. So I'm trying to get one more column on this table that is total minutes for that course. So if this person watched course number 1, well, how many total minutes was course number 1 watched? This person watched course number 2, how many total minutes was course number 2 watched? So if you want it as another column in this table, a window function is a really nice way to do that. So let's try to get that extra column. Okay, so in this case, we're talking about total minutes. So when I hear someone say total minutes, I think sum, right? So our function or our calculation here is going to be sum. We're going to sum up the minutes watched column. And I know I'm going to use a window function. I've already told you we're going to use a window function. So let's do over. And I like to go ahead and alias it as total minutes. Okay. Now it's just a matter of, do we need partition by? Do we need order by? What do we need to go in the middle here? Let's read the question one more time. We're trying to get the total number of minutes for each course as a new column in that table, and then we're going to do the fraction of total minutes next. But let's go ahead and say we need to do this per course, so that's going to be a partition by. Okay. And since I'm doing a sum over all the minutes watched, I don't actually have to order this at all. The order that those rows are in doesn't matter to me. I just need to sum everything up, right? So you'll find this quite often when you're working with window functions. If you're doing something like a ranking problem, order's going to matter. If you're doing something like a summation or an average, as long as you don't care about when that summation and average happens, then you may not need the order by, right? Okay, so let's try to run this one and just see what happens. Okay, so just as we wanted, we still have the same table as before, but we've added on a new column called total minutes, and that gives us the total number of minutes watched for that particular course. So course number 1 was watched 120 minutes overall. If we scroll down, course number 2 was watched 210 minutes so far, and so on and so on. So the reason why you may want something like this, especially for this problem, is now we can say here was the question, find the fraction of total minutes of each lesson contributed to the overall total. So I can do things like finding percentages or differences or so on by directly comparing the minutes watched against the total minutes for that course. All right, so that was one column. Next, I need another column that is the minutes watched compared to that total minutes. So this is another one of those, what you'd probably love to do for fractions here is say, okay, minutes watched divided by total minutes, like that, right? And no dice, right? Again, the window functions are happening after the where. They're happening after other column creations. They're happening later, later, later. So you don't have access to this total minutes column until after everything's been run, okay? So your options are, in this case, you could go to a CTE, which is what we did before, or what you can also do is just copy all of this over and just do it again, right? That would also work. You could, there we go. You could put the window function in again, and then this can be like minute course fraction, something like that. Something along those lines. So yeah, so you could have either put everything in a CTE and then reference that column, or you can do the entire window function again as a denominator here. And I may have forgotten something. I have an extra. Let's see, there we go. All right, great. So now we can see that we have the minutes watched, we have the total minutes for that course, and then we have the course fraction. This first session that this user did contributed to about 21% of our total minutes for that course. So really powerful stuff. I think this stuff is so cool and interesting because these kind of calculations come up all the time. Whenever I'm doing data analysis in SQL or otherwise, I feel like I need to do this kind of thing all the time. Compare group aggregates to individual rows. And window functions are really, really strong way to do that in all kinds of platforms. Yeah, if you work in other things, I do Python polars all the time. They also have an over where you can do these window functions there too. It's pretty cool. All right. Any questions about this one? You can also, I won't show the code here just for timing purposes. You can also use these window functions to do running tallies. And the only thing about that that's a little bit different is you'll be doing the, actually, we can probably actually, let's just adjust this one. We can do it real quick. I'm going to delete this out. Let's say instead of having the total minutes, let me show you this one again. So here I've got the total minutes for each course ID. What if I wanted the total number of minutes so far at each point in time, in each point in activity date? So if I wanted, by the time this user completed their activity, how many minutes have been watched for this course so far? If I want a running total, I could do that by now just adding order by. So if I now just add order by activity, date, there we go. And we want this ascending, right? Because we want to know how much total as time progresses. This is another really cool way to use window functions is that when I hit go now, there we go, I'm seeing how much time is accruing as time goes on, or how many minutes, well, time and time, how many minutes are accruing as time progresses for each course. We're still doing this on a course by course basis. So we start the first, you'll also see that things have been sorted by activity date now because that's how we've done the order by. We start off in November 2023. Somebody watches 30 minutes of course number 1. Someone else starts watching in December 2023. They watch 25 more minutes, so that total increases to 55 minutes. So, and eventually when we get down to March of 2024, we've watched 120 total minutes for this course. So yeah, so that's another really cool way to use window functions. And all I did differently was I added the order by activity date or some other date that you have in your columns. Yeah. Any questions about that one? Because that one's pretty cool too. It's kind of like, a way to get your cumulative amounts. Okay. All right. Okay, so we do have like a tiny bit of time left. So let me just do a tiny bit about these analysis patterns. And again, you have the slides, so you can look through them a little bit on your own if you'd like. So we won't go through everything, but just to kind of give you an idea of what's in this section. For the analysis patterns, there's going to be a couple of patterns that you may see over and over again when you're working with data in SQL. And so here are some of the common problems that people solve. Top in per group. I see this one a lot. We actually, I think, already did it, right? We looked at minutes watched, and we got the top 2 per course. That's one where you can use the same pattern over and over again. Outlier detection is another one that I see a lot of people try to do, or cohort retention. So labeling people by the month that they signed up and then watching how their retention changes month after month, like how many people are still with us after 3 months or 4 months or so on. And also month over month growth is also really popular that I see a lot of people trying to do. So let's see. Which one of these do we want to attack? Let's do the top N per group. We kind of did a little bit of it so far, so let's just do that one to give you a flavor of like what's in this section. So let's say that you had a bunch of events that happened and you have a couple different categories and the values for each of those. Doesn't really matter what these go to, but yeah, you have some kind of category and some values and also some dates there. Top N per group would say things like, who are the top 2 users per category by total value? Basically, the way you want to address this is you would aggregate user totals across categories. You would rank the total aggregates. And then you would filter down to the top 2 users per category. As we saw before, filtering down to those top 2 users may require you to write a CTE or do something else because you can't directly filter off those window function results. So in this case, we'll start by aggregating users across category. So let's say that we want to know the top 2 users per category for each of those categories. So you'd start with a CTE to define these aggregates, right? So with totals as, select the user ID, select the category, and also give me the total value, sum up over all these interactions. So maybe the first user has done 3 actions in category A, and we're going to sum up all of those values. Maybe they're buying products or they're spending time on your platform or whatever it is. You're summing up over all of their actions in that particular category. From events, grouping by category and grouping by user ID. So that would be the CTE that you set up front. You'll end up with now each category, each user, and the total value of some column. Again, prices, dollars spent or time spent or so on. That's your CTE. Then you may decide to, I guess this one I might have created a second CTE, right? I did. You can create another CTE. I mentioned before when we were talking about these, you can go on and create several of them if you want. So this one's my second CTE called ranked as, select user ID, category, total value, rank over, here's where I'm using my window function, sorry about the spacing again there, partition by category, because we want to know the top 2 users per category. So then we need it, the per category is what is alerting you to the partition by. And we're ordering by the total value. Again, ranking problems will often have that order by because you need, ranking usually is like sort them first before I give them some kind of rank. The total value, that should be descending actually. Sorry about that, descending. Well, I guess it depends, but usually you want to find the person that spent the most money or spent the most time. Okay. All right, from total. So we have 2 different CTEs. And then we're able to, that's our second CTE. Then we're able to filter down to the top 2 users per category. Oh, one other thing to notice here. Oops. One other thing to notice here. Did I not put from? All right, from should be in there as well. Sorry, this slide got a little messed up. From is actually going to be from the first CTE, right? So we actually should have from, I think it's called total values, is the one that we're pulling from, okay? So this is another really cool thing about CTEs. You can, again, sequentially reference them. So you define the first one, The second one can reference the first one. So in this case, it should say, oh, maybe it does the next one. There, from totals. Did I call them totals? I called it totals. So that's the first CTE. So that's something else that's pretty cool about them. So I'm actually referencing the CTE before. And then we're filtering down to the top 2 users per category. We have category, user ID, total value, and from ranked, that's our second CTE. And we're saying the category rank has to be less than or equal to 2. This is, again, kind of similar to what we did a little bit in the demonstration. We're just now able to reference the window function because it was in a CTE. And maybe you want to order by the category and the rank as well. In your results, so that was the main query. In the results, you're able to see per category who's the top user and the second user. Some of these, this is just a small table, so some of these only had 1 user per category, but we're able to actually see user number 3 did the most, had the biggest value for category A, and so on. User number 1 has actually done 2 actions in category A, so we summed those values up to get 25. Yeah, there's what I was just talking about. Okay, so your pattern for this one, for the top n per group, is aggregate, find your total aggregates. That was the first CTE. Then rank those. That was your second CTE. Then filter. All right, so that's going to be the only pattern that we have time for today, just given time constraints. But that's what you can expect in the rest of the slides if you want to take a look at those. I've tried to break down some of the most common data analysis patterns into 3 or 4 steps. Like this one's aggregate, rank, filter. Other ones have other steps as well. But yeah, you can take a look at those in the slides. With our final few minutes together, I just want to kind of wrap up what we did today. You did do a lot today, so thanks for hanging in there with me. So thinking about what we achieved today, our first learning objective was to clean and transform data directly in SQL. And this is, probably the number 1 task that you may be assigned doing, is just cleaning up things so that you can even go on to work with that data. As we saw a couple different times, those tildes or those spaces or the so-ons, if we don't clean those up, we don't have accurate groupings and we can't do further analysis on anything. So this is kind of your foundational task. So in this section, we found and then filtered missing values. We used is null or is not null to find them. We converted between data types. We're using cast. We manipulated strings, and this was a really fun, interesting one. We can get rid of junk characters with replace. We can use trim to get rid of white space on either end of our string. And then we can use lower or upper to make our case standardized throughout all the strings. We also worked with some dates. We did extract, which we were able to get the year, or you can get the month or the day or whatever you need from a date column. You can do interval. I didn't do it in the examples here, but you can add like 7 days into the future or 1 month into the future. You can subtract off a year, whatever you need to do with interval. And date format is another one where you can convert your dates back to strings, but you can be very specific about what that string should look like if you need to. We also spend some time bucketing data into categories with the case, when, then, end. With these case expressions, they're very, very useful. You just have to be very careful about the logical flow. Remember that the very first when then is the first one that gets checked. If that is, true, then you got your value and you won't even hit the rest of your when thens, right? So you want to usually put the very most important one first, right? And then go from there. Just pay attention to the logical flow. If that is not true, you pop down to the second one and so on. The other thing about the case expressions that's really important is to have an else. If you don't have an else, I don't know if we showed it in the examples, but if you don't have an else and something doesn't meet any of the criteria, you will get missing null values. So oftentimes, pretty much if I'm writing a case expression, I'm also going to put an else in there. Just what should happen if none of these other things are true? Otherwise, you'll end up with missing values. Maybe that's what you want, but usually you're going to have some kind of else in there as well. Then we moved on to combining and querying from multiple tables. This was also a really cool section. We spent some time talking about subqueries and derived tables. So that's anytime that you have a select query within a select query, that's going to be a subquery. And the derived table is specifically when that inner subquery is giving you tabular results. So you'll often see that in your from clause or your join clause, somewhere where you're working with tables. If you're getting a subquery there, then that's a derived table. I advocated as strongly as I could for CTEs because I do think they help a lot with readability. So if you do find yourself creating, especially complicated derived tables, you can just pop that out of your main query and do with my CTE as, and then you can continue referencing that CTE throughout your main query. It just helps people be able to read your code, helps you remember what code you're writing, and those kinds of things as well. We had cross joins and self joins. This was kind of a lighter section. We didn't dive into it too deeply, but I think it is important to know what a cross join does, and also that you can do self joins, that you can join a table to itself. The examples we used were like making pen pals and making course to course recommendations, but you can also imagine things like, let's say you've got manager IDs in a table. You could build out an entire org chart by doing, by joining, joining a table with itself. You could say, well, who's my manager? Okay, great. All right. You can stack results with union. So joining, I like to say it as it's horizontally joining information, stacking information, and then union is vertically stacking it. So one table on top of the other. If you don't need any kind of deduplication process, then I would recommend going with union all because it's a lot faster. But if you do need to do some deduping, go for union. And our last big section that we spent a lot of time on was window functions. That helped us perform complex aggregations and rankings. So if you're going to build a window function, you'll have over every time. Then if you have groups that you're trying to split things out, use partition by. If you need to sort those groups, or if you need to sort the original results without groups, you're going to use order by. And if you need to rank individual rows, you can use rank. Another popular one that we didn't get to go into here, but is also useful, is called lag. Lag will basically give you the row before. They give you the information that comes one before yours. So you can imagine how like month over month would use lag. You could say what happened the previous month and put that on the same row as me, and so on. Or to summarize or compute a running tally. So we talked about sum or average, any of those aggregation statistics. Someone asked here in the chat as a question that I mentioned something about Python using window functions, and what is that again? So I was talking about Python polars, if you happen to be using that. It is .over, same as SQL. You'll use .over and you can do window functions there. If you're using pandas, I believe it's called transform, if I remember correctly. I think it's .transform. Okay. And the final thing that we didn't quite have a whole lot of time for, but we looked a little bit about solving the real world data problems. We took a little bit of a look into the top n per group, and that pattern was aggregate, rank, filter. Other patterns you can find in these slides for outlier detection, summarize, compare, flag. For cohort retention, that one's a little bit more complex. You'll need to come up with cohorts, do time alignment, count everything, and then do the retention. Or month over month growth, you'd basically be finding monthly totals, looking for the previous month with lag, and then doing the growth calculation. So I hope all of you continue using all of these methods, but definitely, for best results, definitely got to practice, especially if you can practice them in your everyday work. If you can actually apply these to your work or your research or your personal projects, that's when you'll really start to retain the knowledge for sure. And you can also explore other SQL resources. There's a book by Kathy Tanimura called SQL for Data Analysis. It's great. There's also, if you like live courses like this one, there's one called Advanced SQL Queries in 90 Minutes by Alice Zhao. So that's another one where you get to practice your advanced queries in only an hour and a half time. And I definitely have to say thank you, everyone. This has been such a pleasure to host this one. Please stay in touch. I'd love to hear from all of you. There's my LinkedIn and YouTube and GitHub and all those things, website and so on. So thank you so much.
All right. Well, thank you so much, Kimberly, and thanks everyone for attending today. In just a moment, you're going to see a course evaluation on your screen. If you can take a quick minute to fill that out, it really means a lot to us, and your feedback is always much appreciated. I know Kimberly will appreciate it as well. And you will receive the recording link from today in your email within 24 to 48 hours. So with that, we'll go ahead and wrap up the session. Take care, enjoy the rest of your day or night, and we'll see you next time.